only divert carbon dioxide and methane emissions, but also turn those into valuable commodities like fertilizer and energy. That's me.
Excellent. Let me just swivel a bit. Good morning, everyone. My name is Mark. I've been with Shell most of my career, which is now more than 23 years. I'm an engineer by background, physics. I started Shell in petroleum engineering, so I was on the dark side for about 20 years. I was involved in developing some of our corporate strategies as well. And it's in that capacity that we looked at our energy transition pathways as a company. And I've joined what we call the low carbon solutions business based out of Singapore for the last 3 years. So now when I'm let's say, position on the bright side, we're looking at how can we decarbonize our own industry, but also work with customers who we sell our products to, which we call Scope 3 emissions, and how we can help to decarbonize these customers and work with them to identify what are their energy decarbonization pathways. And one of those pathways that I'm working on and trying to establish a business in is called carbon capture and storage, and it involves essentially three key elements that we're trying to demonstrate. One is the technical proof of concepts. Now, in fact, that concept exists. We have numerous assets and projects in operation globally involved in CCS. The second bit is around proving that there's let's say, an investment market, a willingness to pay when there's customers that are eager to pay for this decarbonization service. And unfortunately, it is an expensive service, so that's a struggle we're currently facing. And then thirdly, it's working with governments to implement, design and implement the policies and regulations that are needed. Particularly in this region, we need to look at cross-border policies, because a number of the countries, the emitter countries like Singapore, do not have the domestic storage solutions. They will need to work with their neighboring countries, and hence we'll need G2G arrangements to transport and then store, which is effectively a waste. And so that brings in all sorts of policy issues. Thank you so much. Look forward to today.
Hello, my name is Karen. I'm from NG, so my role in NG now focuses a lot on decarbonization, of providing decarbonized cooling in Southeast Asia. I have about 15 years of experience in the energy and sustainability space, working in startup, large corporates, as well as even government-linked organization. So I'm very excited to meet some of the startups and looking forward to hear more from you. Thank you.
And so the run of show, we will begin with 3 startup pitches, followed by a brief break, followed by 2 more. Then we'll convene for lunch, and then we'll have the remainder of our startups. Then we will have an excellent keynote by Professor Theodore Kojayanu, who will talk about sustainable financing, and I think will be really beneficial for all of you. Lastly, we'll have a brief break for some deliberation, and we'll be announcing the winner of our semifinal at the end of the day. And as a reminder, the winner of our semifinal will receive $5,000, and the top 4 startups will proceed on to our grand final in Boston. So thank you all. We're excited for today, and now I'm excited to introduce Ronnie for a few remarks from SMU.
Good morning, everyone. My name is Ronnie, head of the Urban Sustainavator, SMU's new accelerator focused on urban solutions and sustainability startups from around the world, anchoring them into Singapore to help them scale into Asia. It's a real privilege for us to host all of you here for a milestone moment. The Asia semi-final of the MIT Climate and Energy Prize, held in Asia for the very first time in the competition's 18-year history. It's especially meaningful to host the MIT CEP because many CEP teams are developing breakthrough ideas that could naturally flow into Asia's deployment ecosystem. exactly the pipeline USI was built to host. To our friends from MIT, founders joining from across the region, judges, investors, and corporate partners, thank you for being here. This is not just a competition. It's the beginning of what I believe will be a deeper, longer-term collaboration between MIT CEP and Singapore's deep tech and climate tech ecosystem. As many of you already know, the MIT CEP is the world's longest-running university competition in the climate and energy space. Since 2007, the competition has supported more than 315 teams, and its alumni has raised over $4.5 billion in follow-on capital. And today's event signals MIT's CEP's confidence in the growing depth, talent, and ambition of founders across Asia, and the importance of the region in tipping the global balance towards sustainable net zero future. At SMU, and particularly within the Institute of Innovation and Entrepreneurship, we have long believed that climate innovation must be global, collaborative, and mission-driven. And this year's Asia Semi-Final arrives at a perfect moment. Just 2 weeks ago, Singapore announced the Budget 2026 with a strong focus on strengthening the innovation and deep tech ecosystem. In particular, the expanded Startup SG equity investment program now provides 1 billion Singapore dollars to support growth stage companies, especially deep tech and climate tech ventures that need longer-term capital to scale. Today's event is also part of the kickoff week of USI's inaugural cohort, which brings together partners from science, industry, government, and venture capital. Having MIT CEP here this week creates a natural and exciting synergy, which was quite apparent at the investor networking dinner yesterday. There is also a deeper strategic reason why this Asia event matters. Asia will account for more than half of the global energy demand by 2050. Our region is urbanizing faster than any other. And Southeast Asia alone is projected to require more than $1.5 trillion in energy infrastructure investment over the next decade. Climate innovation in Asia is not a side story, it is the story. And Asia's climate challenges cannot be solved by any one country, one university, or one institution. The future will be determined by two things: talent, because we need thousands of new founders, builders, scientists, and operators, and collaboration, because climate systems, supply chains, capital flows, and technology pathways are deeply interconnected. This is why bringing the MIT CEP community together with Singapore's innovation ecosystem and SMU's network across industry and government is particularly exciting. Our hope is that the CEP Asia Semi-Final becomes a recurring anchor in Singapore's climate innovation calendar, just as the Boston Grand Final anchors the global climate and energy startup scene. I hope that the conversations you have today in the judging rooms, the corridors, and over coffee lead to collaborations, internships, pilot projects, investments, and lifelong partnerships. On behalf of SMU, the Institute of Innovation and Entrepreneurship, and the Urban Sustainator, a warm welcome to all the teams and wish you all the best.
Thank you. And first on deck will be Alban. Excited to hear your pitch. As a reminder, each startup has 10 minutes to pitch, followed by 8 minutes of judging Q&A. You'll see a timer here that Amanda's keeping, and so you can check your timing there, and please try to respect your time limits. Okay. Hello? Hello?
Hello? Hello? There we go. Rivers are the veins of our planet. They feed communities, cultures, and ecosystems. But today, we're poisoning this lifeblood. Around the world, wastewater is poisoning our waterways. The result? Well, that's explosive toxic algal blooms that choke our rivers, block out sunlight, and trigger cascading ecosystem collapse. But this isn't just a local problem in Australia. This is a global environmental and economic crisis. And the flow-on effects to other industries is drastic. In 2025, there were $350 billion in economic losses from mistreated wastewater across the globe. There were also $22 billion spent on energy for wastewater treatment and over 500 million tons of carbon dioxide emitted from this process. Now, agri-food facilities, whilst they're only a smaller portion of this much larger market, per kiloliter, they are one of the worst emitters and have one of the most expensive wastewater treatment processes. Their wastewater is extremely chemically and energy intensive to treat, hundreds of thousands of dollars every single year. They pay sludge costs in the millions, and they are facing mounting fines as regulations tighten. Now, all up, these costs can total over $2 million every single year in just OPEX, and they face compliance risk and shutdown if they don't change. We clearly need a better solution. At Albon, we're turning wastewater and sludge into value using an engineered algae and bacteria system. So how does it work? Well, current treatment leaves behind 3 expensive problems: wastewater, carbon dioxide, and sludge. Albon's solar-powered plug-and-play system feeds on this waste. Our algae and bacteria consortium break down the organics in the wastewater, ensuring that the water is completely regulatory compliant. We then separate out the water from the algae and combine the algae on-site with sludge, converting it into biochar fertilizer through a pyrolysis process. The water can now be reused on-site as well, or discharged. So why hasn't this been done before, and what's innovative about our solution? Well, it's very difficult to do for 3 core reasons: hardware, process, and data. Albon is developing a novel reactor geometry, allowing us to achieve enhanced algal growth rates. And this is a patentable configuration. Methane capture is already very prevalent on many agri-food sites, but we're taking the next step, and instead of facilities simply flaring this, we're able to redirect their flue gas and use it as the fuel source for the pyrolysis process. Once the pyrolysis reaction takes place, we then capture this CO2 that results from that and use it to dry our biomass, and then finally re-inject it back into our photobioreactor, helping improve the algae's growth rate. And finally, data. Every deployment generates us a lot of data points, and we're developing an AI and machine learning model with an industry leader to make sense of all this data, so that with every deployment, our system becomes more efficient. So we're starting by selling these wastewater treatment systems to meat and dairy facilities. And that's because these facilities have the worst wastewater out of all agri-foods, and they have the highest pain point need. And with the biochar we generate, we're going to sell that B2B to fertilizer and soil blend partners. Each wastewater treatment system is sold for $150,000. That can be paid upfront, or it can be financed over time, because we understand that clients care about their cost structures. We then charge them an ongoing sludge and servicing fee, which is up to 40% lower than what they are currently paying to cart sludge off-site. And with the biochar we generate, we sell that for $2,000 per ton. And the feedstock, well, that's completely free, because sludge is a waste product for them. They're paying up millions of dollars to get rid of this sludge. So we started out in my backyard just over 2 years ago with a simple proof of concept. And this was built for a fraction of the typical cost, and we managed to double algal density within a week. Since then, we upscaled to a government-backed pilot, where we're testing our system's performance on real wastewater conditions. We simulated abattoir wastewater. And this was great for our team to understand the hydraulic retentions and how the flow mechanisms work with our system. We've recently received a letter of intent for a paid pilot in the middle of this year with a commercial dairy facility. And we've also received an expression of interest for a paid pilot with a meat processor next year for $250,000. So this is real validation that our solution is addressing real customer pain points and they're willing to pay money to fix this problem. We're hoping to raise a pre-seed round at the start of next year to fund R&D for the 18-month period at that meat processor. And following that, we're going to raise a seed round and then scale this across Australia, reaching $12 million in revenue by Q4 of 2030. So one thing we've learned from talking to all of these different customers is that Albon needs to integrate with what they already have on site. So Albon is modular, it can integrate with what they have on site already, and we actually can integrate alongside the infrastructure, lowering the energy costs and the chemical costs across the whole process. So typically a wastewater company, they're only able to sell to a facility every 1 in 20 or 1 in 25 years. But that's because they're competing against the infrastructure that's already on the ground. So facilities only upgrading in those timelines. Whereas Albon, we're competing against OpEx. So we can sell to any facility at any time. And at scale, as you can see here, a system fits within just half of a football field, which is considerably less space than a lot of other algae biotechnology companies out there. And our integration of AI as well within the system means that operators don't need to deal with managing the algae, because that's the last thing they want to do. They're professionals at agri-food processing. They don't want to have to deal with algae. So we're starting with the agri-food wastewater market in Australia, and that's because the pain point is clear and we have customers that are willing to pay for our solution. But beyond that, we're going to scale this to the US before expanding to the global agri-food wastewater market. But our real ambition is to eventually scale this solution to the global waste and wastewater market, where there's a $713 billion global opportunity by 2032. And if Albon were to service just 5% of this global market, we could clean over 3.6 trillion liters of wastewater every single year. And that same process, well, it would capture over 10.8 million tons of carbon dioxide every single year. And that's the same as planting 514 million trees. We've raised $87,500 to date, and that's allowed us to fund our council pilot and preliminary lab testing. We're raising another $250,000 in SAFE and grants at the moment, and that's going to go straight into our dairy facility R&D and scale-up project. And this dairy facility pilot is incredibly important for our team and our validation, because this is going to allow us to generate the real data points that we can build a case study with and go to other agri-food facilities and tell them what we've been able to do for this dairy farm. So with the MIT's money, it would go towards this, and we're actually able to match it with Australian government grant funding as well. So 2 times value for MIT's investment. And we're the right team to deliver this level of real-world impact. John has worked in aquaculture, managing over 200,000 litres of bioreactors before we began Albon, and also has experience at S&P Global. My background, it's in finance and accounting. I've got industry experience alongside study at Wharton Business School. Our CTO, Andrea, has worked for over 18 years in the wastewater sector with senior engineering roles at Suez and Oricon, and she has a PhD in chemical engineering focused on wastewater and algal biotechnologies. Jennifer, our principal engineer, also has wastewater engineering experience in the US, and she has good experience in process and controls engineering. Dr. Xiaoxi Wu is a photobioreactor expert. He previously spun out a $70 million algae biotechnology company from MIT in the early 2000s, and he has also a PhD in biotech engineering. Dr. James Joyce has a PhD in chemical engineering, and he was one of the first Australians ever to commission a continuous sludge to biochar facility. We've been globally recognized for our innovation by leading universities and accelerators, such as the Global Holt Prize in London last year, and actually the MIT Climate and Energy Prize semis in Munich last year as well. Please join Albon in capturing change for our rivers, our farmers, and most importantly, our future. Thank you.
Can I raise questions? Yeah, I've got a few questions.
Yeah, please.
Thanks, Tom. Sorry for Jerry.
This is John.
John,
Yeah.
thanks.
Tom and John.
Tom and John. Now, a few questions. So The products that Alban provides are the modules and the kiln for that 150,000 as a cost. I just wanted to get that clarified. And then I wanted to understand, when you bring this into operation for that cost, what sort of organization, what sort of operational requirements are involved to manage the system? What sort of organization would you have in place to manage that, to ensure that there's quality control of the output? And what sort of liabilities could there be in the form of when, you know, your products don't meet the specifications required?
Yeah, so that $150,000 initial capex does cover both both the pyrolysis as well as the wastewater parts. We're primarily cutting down on their OpEx cost to incentivize and also allow us to introduce that low capex up front. When it comes to actual management of the system, so the wastewater tech typically on site is already managed by an operator. However, we're trying to take the hands off of that operator by using machine learning systems to help with that wastewater process. So that operator actually has a lot more free time to now work on the actual movement of sludge to the pyrolysis kilns. So some of the facilities we currently have visited already store their sludge, dry it, and then remove it off. So it's pretty much just one extra step that we're including that they can move it into to reduce the total sludge that they're moving on site.
And in terms of getting the module systems to site, so that's really something that we're going to be focusing on the next, after our pre-seed round, we'll be really building out the technology and getting to a point where we can have it entirely manufactured, pretty much good to go, so that it's done in the factory. We just have to put it down on site, connect in our pipe to the water, connect our pipe out. So in terms of the construction, it will be the commissioning process. We're trying to simplify as much as possible, but definitely we have a team of contractors that are going out to each site. We have a leader from our team who's helping these contractors and guiding them about what we want on site, what's essential for the outlet system to work.
What is the,
I think we have another.
what is the net CO2 emission considering pyrolysis is inside in one of our process which is energy intensive?
Yes, so the net CO2 emissions actually is mitigated compared to typical pyrolysis processes. So we're taking use of methane from the wastewater process to help kickstart that energy process. The final CO2 flue gas that's released is actually used as our CO2 stream for the algae. So typically for other algae companies, this is something that's an ongoing OpEx for them to pay, which is not the case for our business case since we're having an ongoing stream of CO2 from earlier processes. So no net emissions from that process.
Okay.
So. Thank you, Team Alban. And next up will be Climacell. And if the startups can just use the mics so it comes through our live stream, we can hear you back in here, but for our live stream, that would be great. We've got 2 mic packs up here. Thank you. Working.
Cooling buildings is becoming one of the fastest growing sources of global electricity demand. My name is Fatimda. I'm the co-founder of Climazetl. And at Climazetl, we are solving this problem. We producing heat-absorbing panels that reduce temperature swings and also we made the buildings cool without air conditioning. So the buildings use about 40% of world's energy, and a huge part of that goes to cooling. In fact, 15% of global emissions come from the energy used to cool buildings. An estimated 90–70% of the buildings should need to be upgraded to achieve higher energy standards by 2030. So to tackle this problem, we have developed smart panels that work like heat batteries. These panels are made from phase change material that absorb excess heat when the temperature rises, reducing demand for air conditioning. At night, temperature drops, panels release the stored heat and regulate room temperature again. So basically, instead of using more electricity to cool buildings, we store the excess heat inside the ceiling itself. Can phase change material absorb all the excess heat in the building and freeze the space? The answer is no. And that's not the goal. The phase change material does something smarter. They don't eliminate heat. They absorb excess heat when temperature rises, and they release it back when temperature drops. So we are not replacing air conditioners. We are flattening the temperature swings. And this matters because air conditioners consume the most electricity when fighting the sudden temperature peaks. And by reducing those temperature swings, we can reduce the compressor workload. And we can also adjust the material mix to suit different climates and temperatures. So the core of our technology is specially designed bio-based phase change material. We use 100% bio-based fatty acid as our thermal storage composition. In order to make shape stable and prevent the leakage, we embedded it into expanded graphite foam structure by using proper cross-linking. And this results in a stable thermal panels with high heat storage capacity, zero leakage during phase transitions, and flexibility to be manufactured in different sizes and shapes. We spent fully 1 year in laboratory to develop and validate our materials. This includes thermal cycling tests, leakage tests, and performance measurements in control systems. Beyond the lab validation, we tested our panels in small home models, container houses, and this shows a 4 degrees Celsius reduction in peak indoor temperatures with a full daily cycle. So we can put these panels on ceilings, or we can create such type of designs in the walls as customers wish. For our climate impact analysis, we use impact forecast tools and official international energy data to model 1,000 square meter buildings in Azerbaijan. By using the global cooling demand data and national grid emission factors, we calculated that annual cooling building emissions decreases from 23.3 tons CO2 to 16.3 tons by using our panels. This is a total reduction of 7 tons of CO2 per building per year. At first glance, this may not look massive, but the climate impact is never about just one building. When we step back and look globally, we see the picture change dramatically. Globally, cooling buildings are projected to be 3.4 gigatons annually. And with our panels implemented in buildings, this can reduce to 2.4 gigatons. So it's a total reduction of 1 gigatons annually. As cooling demand increases, decarbonization is not an optional. In Europe, the Green Deal requires 35 million buildings to upgrade for higher energy efficiency by 2030. So, and this creates an $18 billion market for us. But we are not starting Europe. Instead, we are starting at Azerbaijan, where the market offers a $500 million opportunity for us. And in this market, we can quickly validate our performance in real-life buildings and also provide our ROI. So for a 1,000 square meter commercial building in Azerbaijan, the Climazel reduces HVAC energy consumption by 25%. This translates to 6,700 euros in annual savings. With a total capex of 35,000 euros, the full financial payback time is just 5.1 years. We sell our Climazel panels at 35 euros per square meter directly to building owner and construction companies. As our operation scales, the unit cost will decrease from 15 euros per square meter in 2026 to 11 euros per square meter in 2028. This will create a strong growing margin for us. The PCM sealing solution is used from other companies for more than 3 years. For example, our closest competitors is Thermocool, and they use micro-encapsulated PCM into gypsum panels. But this micro-encapsulation reduces the heat can be absorbed, also make the expensive product. And within this system, the temperature swings still occur. Rubitherm uses the metal case PCMs, which make the insulation complex and add unnecessary weight on the ceilings. And also the Armstrong company integrates the PCM into only ceiling tiles, but the walls remain inactive. So the temperature swing still occur in the building. But our technology and approach is different. We integrate our heat absorbing material directly to specific foam matrix. And this makes our panels lightweight, leak-proof, cheaper to manufacture, while allowing it absorb the heat and transfer it in a very faster. So in 2024, we developed our MVP, completed pilot project in container houses, laboratory tests, and received $27,000 in non-dilutive funding. In 2025, we joined CBC Accelerated Program, received 30,000 euros in grants. We also made 85 customer interviews for product validation, and today we have 5 buildings ready for pilot projects and 2 partnerships in Netherlands. By 2026, we will receive 300,000 seed investment and deploy our Climazel panels across 1,000 square meter building in Azerbaijan. In 2027, we will get our Europe CE and licensable patent, which allowing us to scale our operations in Central Asia and Europe. In 2028, we will enter the US market, reach 1 million square meter globally, and reduce 40,000 tons of CO2 emission. Our team combines expertise in advanced materials, financials, polymers, and cross-linkings with support from advisor who has experience in lean methodology, entrepreneurship, building science-based company, and working with major energy firms. So winning this $100,000 prize, we will rapidly deploy our Climazel panels across 100 public buildings in Azerbaijan and complete our pilot projects. So dear audience, join us and help us to turn a sustainable future into reality. Thank you. the Europe market, we will sell our panels to these construction companies. In Azerbaijan, actually, we talk a lot of companies, but most of them didn't want to climb the panel because this is a new technology that people have so much information about this. So they are a little bit more skeptical, like they didn't believe that this panel really works. So we want that to conduct these pilots to get real life data that people see that yes, we can really decrease the carbon emissions and also electricity use. So we can enter the market with real life data.
I'm not an expert at building materials, but I would think, I mean, you're facing developers who would probably like to have scale, right? So when they decide to buy this from you or have you as a supplier, then they would need to make sure that you actually have sufficient volume to supply them.
Yes.
And as a startup, actually to scale up.
Right now we are talking with high-tech tech, which is located in Azerbaijan, and we will work with them in order to manufacture panels and then sell.
So you outsource the manufacturing. Right. You will outsource the manufacturing.
Yes, outsourcing, yes.
Maybe I could just build on that question. So, because you mentioned that there's a biosource in your products.
Yes.
Just wanted to understand a little bit more, where does it come from? How easy is it to scale that into your products? And to what extent, does this provide you your IP or your CVP?
So in order to make this product, we use fatty acids and we made these eutectic solvents, and we also add graphite and cellulose. And right now, all these materials can be found locally in Azerbaijan. And so that's why actually we start firstly in Azerbaijan, because it's easy to get these materials. But when we entered the European, Asian market, etc., like these materials, for example, these fatty acids also can be found in China. So yes, these easy materials that can be found in globally. All of them is bio-based. Yes.
I've got a follow on. So, have you done any life cycle degradation tests on your products?
Yes. Actually, yes. Test the pattern.
Yes. Can you hear?
Yeah.
Our panels has 10,000 cycles, and at the end of the life cycle, the panels can biodegrade naturally. And we tested it; it successfully worked like that.
So
And
how many years is that cycle?
Yes, and if we consider one cycle roughly per day, and it makes approximately 20 and 25 years, approximately.
25
yes.
years. So it's effective for 25 years. In
Yes,
giving
and
you a 25% reduction.
And the performance of the PCM cannot change.
So your payback is 5, and then they enjoy 20
Yes.
of reduced energy. And that's been certified with the lab, the tests?
Yes, lab test. Yes.
And that 10,000 cycles, how does that compare to traditional building material?
So actually, our competitors is the companies that use PCM, and regular insulation materials is not our competitors, because this material is not insulation; it's considered insulation materials. They have such property that it can be used insulation, but it's not our main goal. Our main goal is to reduce HVAC systems. So by in the comparison of HVAC system, when temperature swings happens, these air conditioners consume the most electricity. So our main goal is reduce this temperature swing, so make it like more stable. And by that insulation material is not our competitors, but the other phase change material companies, they also have this such type of solution, but they are not as efficient as our panels because they are not absorb that much of heat, and also some of them is not bio-based.
And some of the companies use paraffin-based PCMs, which is flammable, and also others use salt hydrate-based yet, and this is liquids. And also they have 500 cycles overall.
One question. So in your assumption, right, you assume that you're going to save 25% energy consumption per cooling, which is very significant.
Yes.
A lot of companies have to, change their entire cooling system to do that, and that forms the basis of, your value proposition. Can you run through how do you get that 25%? Because from my humble understanding, basically when you absorb heat needs to be removed somewhere. So
Transferred.
At the end of the day, the heat is still staying in the building unless it's being removed somewhere. So how do you justify this 25%, and how do you, ultimately remove heat out of the building?
So we conducted this like as a case study in Azerbaijan, 1,000 square meter commercial building. We calculated that like in Azerbaijan, the weather is not that hot. For example, the maximum is like 30 degrees Celsius in the summer months. So we calculated this like 3 months if the air conditioner system turned on, and how many energy consumed during these 3 months. We calculated these numbers, and with our ClimaZel, as we said, one panel can absorb 75 kilojoule energy. So we calculated that for like this one building, how many panels required, and by absorbing one panel, absorbing 75 kilojoule, like how many energy it can be absorbed by implementing these panels on these buildings. And also for your question, like this panel absorb the heat when temperature increases. When temperature drops, like in the evening, it can be cold outside. In this case, these panels release the stored heat again. So like it's a phase transition, the heat absorbed and released. So the transfer is happen like that.
In the regions like Singapore, where the weather the temperature of the day and night same, the PCMs are not suitable and efficient for these regions. But if the PCM must be used in Singapore or Middle East region, they would be need for liquid cooling over the panels or active fans in order to cool the panels to release the heat, stored
If I
heat.
understand correctly, it's not really removing the heat from the building, it's stabilizing.
Yes, it's stabilizing.
It's
because
stabilizing,
yeah.
and therefore reducing the volatility of the temperature, and therefore the energy consumption of
Yes.
the HVAC.
Yes.
And therefore it would be most effective in an environment where temperature volatility is high.
Yes, you're correct.
And also, I'm curious, what's your estimate of the potential scale, revenue scale of the company, and also who are your competitors, and who is the largest competitor, and how big are they? What's their revenue?
So actually our largest competitors is Thermocool company, which they use microencapsulated PCMs, but this microencapsulation is very expensive process. That's why their product much more expensive compared to others. Actually, put the price of this them. Our main competitor is them, but their price is very high, and also these capsules absorb less heat compared to our product. And actually, for our scale, first.
What's the size of those companies? What's the revenue of those companies? Do you know?
They are. I don't know about the revenue exactly, but they are selling these panels more than 3 years.
I guess one. Thank you.
Thank you. Okay, next up is Earth Sprint.
Yeah.
Testing, testing.
Yeah. Yeah. It's working? Yeah.
Yeah.
Thank you so much for the presentation. I was just So I was just wondering, do you already have off-takers or LOIs with building construction companies that are willing to pivot or use some of this in building actual building projects?
Right. So the ones that we have had are the parking station area, some with university campus. One we have industry who are building solar plants and they require exposure critical flooring, and another with public service department. So these are the ones that are nearby to us and are closer so that we save in cost on transportation and stuff. But the buildings, we are still in conversations with the industrial manufacturers, because it all comes down to the chicken and egg problem, where they want to see first where it's deployed on a smaller scale before they come up for larger contracts. So that's what we are focusing first.
One follow-up question. Your 327,000 revenue, so how many projects would you then need to, or houses would you then need to build if you like to reach that?
Right. Thank you for the question. So basically, about 20,000 meter square of area, which can be anything where it's allowed. And the 327K includes our 41% gross margin as well. So right now, our cost for us is $9.9 per meter square, but extending to a margin of $6.8, it comes to that number. And yeah, so 20,000 meters squared could be anywhere, any industrial manufacturing, yeah, solar plant, or anywhere those who people require this kind of stuff.
I think this is very much the holy grail for the construction industry. Cement is a necessary evil needed to erect that building, but it is the highest emitter. There are a lot of cement companies today that are heavily in cement solutions. So, given that you're a startup, how are you going to change? I know you have a patent, but how are you building yourself from larger players? And then
Right.
my next question is going to be, because you've got a natural feedstock, which is rice, beautiful, logistically and from a manufacturing standpoint of scale, have you really thought about how you not just across India, but into Thailand, or wherever you need to supply? What is your plan? This is a brick and mortar business.
Right. Yeah, thank you for the question. So first question, regarding the cement plants, all the cement industries, basically, they are working on a binder which uses a chemistry that has cement or calcium hydration. So the whole process that they are building are completely different from what we are building right now. So if we take a normal cement manufacturing process, the clinker manufacturing goes at 1,000, 1,200 degrees Celsius. And our process, because we are using aluminum silicate polymer networks, it comes at temperature at 300, 400 degrees Celsius. That's the biggest chunk where we have the CO2 savings. So for them to come into this sector, they need to have the supply chain, they need to have the reactors. The reactors that we are building in-house, those reactors give us an extraction efficiency of 94%, which on further processing can go up to 99%. We have tried as well. And that can be also another stream where this can be given to rubber manufacturers who need actual industrial silica. So that in that case, if they want to really pivot, they have to start from scratch. It's really difficult for them to retrofit the existing facilities to build something kind of this. Now, the second question regarding, sorry, I forgot.
So how have you thought about as it scale, how
Yeah.
you manufacture, how you are you providing potentially to
Feedstock.
larger comps?
Right. So right now we are working on end-to-end model. And regarding the feedstock, we have collaborated with FPOs, the farmer producer organization in India. And realistically, the region that we are operating, it's not even the top 10 producers of rice, but it produces so much of rice husk just in one harvest season, that's enough for us to cover that whole state. So these reactors being modular are not limited to one place. It can be taken to any place where there is rice husk and be put on site during the whole harvest season, get the rice husk manufactured from them. And the second biggest thing is that this has a reduction factor of 1:10. For example, if you put 100 kgs of rice husk, the resultant RHA, which is rich in silica, comes out to 10 kg. So if you really want to just make sure that we get the raw material from India and build somewhere else, we can send it there as well.
So this is a follow-on. Right now in India, that still allowed today for burning? Or?
No. So basically, that's the biggest problem. If you have heard about pollution in New Delhi, and why it's one of the largest or most polluted cities in the world, is because New Delhi is surrounded by rice-producing states. Right. So every season, these farmers, they end up burning this thing. They are getting penalized. They are getting, I mean, government is not saying don't do that. But
there's now a cost for them to have
yes. And we are also paying them. So otherwise, once they were just building or, throwing that or burning away, we are giving them additional source of revenue. So that's an incentive for them to come and even just contract with us that after this season, they're going to give me all the supplies.
Given that you're mobile processing, it could actually be waste management as a service.
Right, yeah. I mean, that's one of the things that also motivated government to collaborate with us and give us the pilots so easy access, because they want someone to come up and solve this issue of crop burning as well as the farmer enhancement.
So geopolymer technology has been out there for a while. A lot of companies, a lot of researchers have been working on it, but not many of them have, successfully scaled up in the construction industry. Why do you think it is, and how would you be different so that, you'll be successful?
Right. So what we are trying to do is one of the biggest things for geopolymers is what waste stream you're using. So the example that we told of the Brisbane airport, they were using the industrial slag, the metal slag from industries. And the issue with that, it varies from place to place, and it's not consistent. And you have to be geolocated to the areas which the place is there. For us, rice husk is almost free. The raw material is free for us. There is abundance. Every year you are going to get replenished with that. So that's not an issue. Secondly, the reactors that we have designed help us to achieve the efficiency of 94% extraction at minimum energy cost. That's why from day one, we have that big margin of 41% to adjust the costing as well as to scale up. So these two things, plus the material formulation that we have done, help us to enhance the property. What people were earlier doing was they were straight away going for the structural cases where they were trying to replace cement as, where the structural load bearing. But that's very difficult. And also that's really risky unless you don't have a years of, pilot or exposure in the market there. That's why we first move on to the market where industrial flooring. It's not structural load bearing, it's easy, and also it faces a lot of issues of replenishment or epoxy coatings and other life cycle issues because of the inherent deficiencies in concrete. So that's why we are planning. Because geopolymer, the qualities of it requiring less water for curing, it being CO2 friendly, so it fits in there for us.
And in terms of the process of producing geopolymer, how different are you from the other solutions out there, other than the fact that you're using rice husk as your feedstock? I'm just thinking, can they do the same as well? And I mean, targeting non-load-bearing material is something that they can do as well.
Right. So what we have done here, the chemical formulation, it's unique. It's not there present anywhere else. This technical, the exact ratios that we've optimized are not present. So traditional geopolymer or any company that want to get into this, they have to first align those ratios of silica, of the existing alkali activators, so that they get the strength. This has been done in-house by us, and that creates another differentiating point. Okay. Yeah. Thank you.
Thank you. Okay, now we'll take a brief 10-minute break for coffee. So there's coffee in the next room. If everyone could just try to make their way back here by noon. The food for lunch has also been put out, so if you want a little snack, you can have one, but remember to be back here in 10 minutes.
Yeah, you blame me for it. My friend, good to see you. Thanks again. I was sitting quietly behind. What? Oh, well.
Sorry about the mic situation. This is annoying.
Founders. Startup founders, if I can talk to you real fast. We can thanks for joining. Do you want to swap some mics?
Yes, you can. I think this one might be better, like might be louder. But you might just have to pass back and forth because otherwise we get
Okay.
like
Okay.
Sorry about that.
Okay.
Yes, so it is green.
Now it's on.
So if you speak,
Just press OK.
Okay, great. We're going to go ahead and get started again. So the first up will be Ecolite.
Okay. Hello everyone, my name is Aytaç and I am co-founder of Ecolite. Today, the global battery market is growing insanely fast, and most batteries still rely on flammable and fast-degraded electrolytes. And that is a hidden problem nobody is solving. But we developed the ionic material that makes the battery safer and longer lasting. What you are seeing in this picture is not a factory issue, is not a brand issue or a factory mistake. It comes from the chemistry inside the battery. Lithium-ion batteries use liquid electrolytes, and those liquids are flammable. Under overheating, stress, or fast charging, they can trigger a thermal runaway. But the battery failures is not only about the fire or safety, it is also about the cost. In order to reduce fire risk, the manufacturers add more protection and cooling systems, and this increases system weight as well as system cost. But these recalls still continue to happen. Also, lithium-ion batteries last only 8 to 12 years, and one major reason is for that battery degradation. And because the conventional electrolytes tolerate only around 60 Celsius, but during fast charging, it creates high spikes. As a result, it crossed beyond that range. As a result, the battery is cause the battery degradation and shortening the lifetime. So our solution is ionic gel technology. It is non-flammable, which means eliminate the fire risk inside the battery. Also, it is a highly thermally stable, even handle extreme fast charging conditions, as well as tolerates the temperatures up to the 200 Celsius degrees. And it is self-healing. Inside, it repairs the internal structural damage inside the battery. And our solution is drop-in compatible with existing production lines. The electrolyte is a transport system of a battery. Efficient ion movement, which determines the performance and power of the battery. While ionic liquids offer non-flammability, high thermal stability, we offer a comparable performance while reducing the production cost by 15 times. We validated our solution at a lab scale. We used dozens of deep eutectic solvents, and after the polymerizing and the electrochemical testing, which selected the best performing ionic gel. Through the lab validation, we confirmed that our solution has high ionic conductivity, electrochemical stability, as well as self-healing property. So our market size is huge. We are looking at global electrolyte market. Within this, our main target is US electric vehicle electrolyte market, we are starting with a faster and smarter beachhead. First, we are starting with light electric vehicle electrolytes, like scooters, three-wheelers, and it will enable us to validate our solution with early adopters before entering to the large scale. Then we know that entering to the passenger EV market requires extended validation and qualification cycles. So we phased our strategy. First, as I mentioned, that we start with light electric vehicles because here in this segment there is a lower qualification cycles, the lower regulatory barriers. It will help us to faster adaptation. Also, then in phase 2, we moved to the small batch production, starting the pilot test and also secure our recurring supply agreements, and then going to the phase 2. In phase 3, of course, it is our last phase, and we move to the EV passenger market. Then this is our B2B model. We directly selling our product to the battery manufacturers, and our selling price is $55 per kilogram. And you see, after the lab synthesis, we move to the lab's pilot batch production, then third-party manufacturing in US, and lastly to the gigafactory scale. And actually, at the early scale, we are in a cash negative. Then from the 2028, we turn to cash positive. And in a long term, we project a strong gross margin with a scalable chemistry and disciplined production. While the traditional liquids are highly flammable as well as not thermally stable, other electrolytes, also ionic liquids, polymer solids, they are either too expensive or hard to scale. But we combine all of these performance, stability, cost efficiency, and non-flammability in one solution. This is our roadmap. You see, in 2025, we validated our lab tests and also secured $12K early funding. This year, we moved to patch cell validation. After the validating, in next 3 years, our steps are entering light electric vehicles, then getting the automotive safety certification, in the 2030, entering to the passenger EV market. Also, average electric vehicle battery production makes 6 tons of CO2, and the electrolyte is accounted for 15% of that footprint. And but with our solution, we reduce this electrolyte demand by 70%. For one battery, there is for electric vehicle battery, there is a need for 900 kilogram electrolyte, but we decreased it to 270. Then, and it is equal cumulative 17 billion tons of CO2 reduction until 2035. Also, we are raising $100K for starting our pilot validation, becoming with the middle of this year. Also for moving small batch production, US patent application, and networking. And this is our team, Laman, also one of our co-founders. Also, it leads to our go-to-market strategy. Then I am Aytaj. I lead electrochemistry, also analyzing degradation and validating the performance. Elmar Askerzadeh has 5 years experience in ionic liquids industry, so it bridges the lab synthesis to the industrial production. And ICEL is a deep expertise with 5-year experience in self-healing materials. These are advisors. Pitambar support us with equipment manufacturing, integration strategy, and Gulnara help us to support us with the independent scientific oversights and validated our milestones. We are generating next generation safer and greener electrolytes for next generation batteries. Thank you.
Lithium-ion battery is obviously a very big market, but also it is very competitive. I just did a quick search, Google search. It shows, I mean, obviously, we are not talking about the Chinese market, but China clearly by far the largest producer checking the price of electrolyte. It's 33,000 RB a ton, which is 33 kg. That's about $5. Your price was showing 55.
Yes.
The price disparity is significant. The price you're showing is 10 times
Bigger? Higher.
than the mature product. So how do you address that? Because at the end of the day, for us, battery cost is everything.
You know that we sell little amount of this material, so that's the reason why our cost is high.
Is what, sorry?
We sell less amount of money, less amount of product, so that's the reason why our cost is
Of course,
high.
we make research. Okay, we make also research, but while our solution selling price is 55, near this we offer non-flammability, high thermal stability, as well as extending battery lifetime, and I think that maybe our indicators are better. Of course, during our research we don't get this.
But if you do the comparison, because my understanding is the flammability of a lithium-ion battery is largely caused by the dendrite between the iron and the carbon,
Yes.
right, the short circuit. So even the electrolyte is inflammable.
Yes, yeah, I know about the dendrites. In the traditional electrolytes, traditional materials, there is a dendrite growth inside the battery, as you said. But in our material, it doesn't happen, or it happen it takes too much time to this happen. Like, so we need more time to happen this. Like in the traditional material, it's
Is this something that's easier to explain why? Because it's liquid. How do you stop that being built up?
Our material is gel, not liquid. So the traditional ones are gel. But now industries want to use solid materials, and we offer them the better one, gel materials.
And also it prevents the leakage. In liquids.
Yeah, same sort. Other question?
I think foremost, thank you for working. I've personally experienced a battery fire, and that's no joke, right? So the sustainability part, on social media you always see vehicles, scooters, they're always on fire. Have you done any independent testing on life cycle, and especially with like rapid charging throughout the cycle of this battery? Does it retain?
Well, our life cycle time is 2000, over the 2000 cycle, but in the traditional batteries there's a 500, and also what did you mention?
So
life cycle and
so independent tests on the life cycle of the battery, specifically now with rapid charging, because that can degrade a battery very quickly, right? So have you done independent lab tests or certifications around the life cycle of the product?
not the certification, but test, yes, we done. And as I mentioned before, our life cycle is over the 2000.
Were they independent tests or your tests?
No, our tests.
Still not inside the battery. We still don't need, we are currently working on it to integration to the battery. But why we know this is suitable? Because from other companies like Solvionic, IonTech, we looked at those companies, and also they have electrolytes, and they are selling these electrolytes to the battery manufacturers in the US in order to making the research and development. That's why, and we looked at their electrolytes indicators, and our indicators even better than theirs. That's why.
So for the test, how long?
Actually, it takes, like the lab scale test, takes 1 or 2 weeks. But if we need SEM analysis or something like this, it takes too much time, yes.
So the amount of tests you've done so far?
It's the flexibility test, conductivity.
No, how long? Because there's a amount of time that you have done to test the material in order to test the material. Otherwise,
Yes.
it's predicted.
Okay. Yes, we started actually our project in 2025 summer. So we do some research and some laboratory experiments to achieve this material in 3 or 4 months. Then in the January we completed laboratory tests.
So the longest duration of line.
It's this.
Actually, as I mentioned, from the middle of the last year, we started for material synthesing. After it's done, we started to what test we said, conductivity, electrochemical, and just we finished actually last year's December, and until now it take our time.
The conductivity test takes too much time than the others because
Just
flexible
3
test
months.
there is a simple device for it.
Thank you so much. Just a few other questions. Have you had market engagements? Have you tested, the technical excellence of your product, the commerciality of selling this, the interest from the market to want to work with you and change or adapt their existing battery manufacturing processes? Because I can imagine that this could be disruptive, or in the sense it would take quite some changes from manufacturers to have to change to a different processing method.
Actually, our solution, as I mentioned, drop-in compatible. How we know that? Because as one of I showed you the solid electrolytes, they are actually researched, they are drop-in compatible. It means that the manufacturers don't need to redesign their factories, just taking the electrolyte from the battery and put the new electrolyte inside it. So from the commercial side and market, as I mentioned before, that we search our other competitor companies that make similar electrolytes and give the battery manufacturers for research and development, but our indicators are better than this. That's why we believe that it is suitable for the market also. We have advantage. We combine safety, non-flammability, also extend the battery lifetime.
And also I want to add, we are not, let's say, talk with someone or some manufacturer for the pilot testing, because we need how to say, we need firstly complete some laboratory analysis too in some industries. So after that we started to search our exactly, let's say, customers.
Also we talked with people from the battery industries actually, then they also say that your solution can be suitable for the battery manufacturer.
So you mentioned you've done some tests with light vehicle battery manufacturers, right?
Not actually. We just do it in laboratory. It is like
so
a
that's
pack.
the plan.
Yeah, that's our plan.
Got it.
But have you already identified some potential parties that would want to work with you to test this, to work towards a commercialization stage?
Yeah, you know that if we want to work with something, we have good results in laboratory, also some certificates about it. So that's the reason why we have to complete the laboratory fully, then start to find someone to work with.
Last question: Have you published any research papers on this?
We are working on it right now.
Currently working for research.
Thank you, great. Next up will be Freesher.
Test. Test. Yeah, it's working. Okay. Thank you. I'll start our pitch in 3, 2, 1. Okay, so imagine losing trillions of dollars while actively generating nearly 10% of food loss every year. Now, ironically, it's not just food loss, it's global emissions. So ironically, this is still currently happening in our food system. And it's all because of a guessing game. Now, in this industry, the difference between a day's error in predicting the food quality is might as well the difference between night and day. You either get a massive harvest or you get a total write-off. So greetings, audiences, and judges. Introducing Fresher, where we take the guesswork out of the equation. We are a comprehensive shelf life and logistic assessment system to alleviate the food waste. Okay, now, we all should agree that food waste is like a global thing that's been happening forever. And actually, we contribute 2 billion tons of it to the global emission. How so is that 40% of food is lost before even reaching the consumers. And with other types of losses combined, and it kept pulling up for the whole year, it goes up to $1 trillion of combined whole food loss and waste. Okay, where it actually happens is that from post-harvest up until the retailing and until it reaches the customers, food loss keeps happening and happening during the distribution. So 13% of it happens during the agricultural to the retailers, and then 17% happens during the retailers up until the consumption. And by our definition, in a supply chain system, there are three main actors, right? The first being the regular farmers, the small-scale farmers who work in actual farmyards. Secondly are the larger-scale farmers who are the middleman or the wholesalers like Dole or Sunpride, for example. And then lastly are the retailers like the supermarkets, like Fresh Market, Ranch Market, and all the other types. Right, so from here on out, we agree that how we can reduce food waste while optimizing revenue for farmers and distributors is that we can approach by our strategy is the dual solution framework, where we have the corrective layer and also the preventive layer. So here we have Fresher, where we decrease the waste by 74.7% by our customer personas. We have two personas here. One is the large-scale agribusiness, which has been said before is the middleman or the wholesalers. And then secondly is the modern grocery chain executive, which are the retailers in person. And, and here it has been verified by user interview. They have verified our hypotheses where the main problem is that we have very subjective testing. Usually it's the farmers who look at the products, they see, oh, the weight, the color, the scheme, the texture, and everything, but it's never accurate 100%. So this is where we come in, because we have been validated by Al-Ittifaq and also Java Fresh, which are two of the biggest supply chains in Indonesia. We aim to reach 10,000 farmers and retailers by this year, while also penetrating 3% of Indonesia.
Therefore, introducing Fresher, a system that combines prediction model, sensors, and recommendation app. Here are our components. First, hyperspectral imaging for fruit and veggie, while thermal imaging for meat and egg. Smart box to receive the data from the sensors. Environmental sensors to check the condition in storage room and transportation. Also Fresher app to integrate and analyze those data. We validate our solution by using established tech and proven prediction model to achieve 98.6% accuracy by using kinetic degradation model. But how does it work? Let's use tomato as an example because we, Southeast Asian people, love spices. However, tomato degrading very quickly in the truck even before it reaches the customer. First, tomato freshness is measured with the hyperspectral imaging. Then they are stored in a storage room with environmental sensors to check the temperature, humidity, and pressure, because we realized the food quality is fluctuating depends on those indicators. Then, our system will analyze the freshness according to the image that is interpreted into the chemical compound. By adding the environmental data sensors, we can predict the shelf life of the food. Then our Fresher app will generate the dynamic recommendation. Here is our app, or our main solution that you can scan there. After inputting the data, the AI recommendation will take into the action. First, if the food is still fresh, then the initial distribution and price are good to go. If they're ripening quickly, the farmer should reroute it to the closest distributors, while retailers get the price adjustment according to the demand elasticity model. However, if the food is spoiling, then they should send it to the animal feed or fertilizer company. Lastly, our app also able to give optimization to storage recommendation and supply amount. Therefore, our business model is a software subscription-based model that charges $30 up to $60 a month. Here is our competitors' analysis based on the analytical depth and decision scope. Therefore, our main competitors are 1/3, Zeslab and AgroFresh. However, they only focus on one decision scope, such as shelf life and also supply chain. Hence, Fresher can enable us to more reducing waste at multiple decision nodes to increase the economic value per input. If we look at it closely, Fresher enables end-to-end data connectivity chain by using multiple sensors to increase the highest accuracy rate up to 98.6%. Our AI recommendation and prediction also enable us to have compounding data intelligence, and we aim to focus on the Southeast Asian market because we want to implement the Blue Ocean strategy and to get the contextualized regional expertise for tropical foods. Ladies and gentlemen, Fresher aims to minimize the environmental impact by 74.7% by reducing the total food waste for more than 2,000 tons per year for each farmers and retailers. We also aim to minimize the carbon emission, water, land, and energy loss. Socially, we want to increase the technology literacy for the employee and reduce the volatility price of the food.
Now, our initial roadmap is laid across 3 years with 3 main entries. The first one is product development, the second one is the partnership outreach, and then the third one is the market entry, where we start from finalizing our MVP, expanding the data set, onboarding partners up until securing enterprise contracts. And within this stage, we project to secure 10,000 total users by optimizing our routing recommendation as well as sensor-based quality assessment to have model validation for at least 25 food types as well as reaching accuracy by up to 98.6%. Now, within our deployment stages, we aim for scalability. That is why we set high accuracy of sensor tag added to various geographies and communities, as well as trying to continuously improving our scoring, routing, as well as pricing recommendation, all using our AI as well as auto system model. It is all done to support our path to market, starting from 5 pilot partners within Indonesia in year 1, which we have been actively engaged with, and then later on started to expand to Southeast Asia via B2G as well as enterprise scheme by the following year. Now, onto the risk and mitigation. We map based on occurrence as well as severity rate. We believe that the proactive strategies should be the one, such as like the payment options as well as for costly ML training, for example, we could do gradual automation as well as mid-transfer. Now, here's how our funding allocation will look like with the priority goes to MVP model refinement as well as the prioritization of the strategic teams such as science, tech, as well as sales background, and then we deliberately plan for the IP as well as data flywheel protection before the market entry. Now, our financial model shows strong positive result generating within payback period of 2 years at an NPV of $969,000 and having IRR of 39%, all within our recurring revenue as well as scalable deployment. And within our calculated simulation for our clients, it shows that we could actually save by at least $7,000 as within payback period 1 to 3 years. And then these feasibility studies showcase that with prospective funding allocation, we could actually generate strong financial viability. So judges and audiences, with our awarded cross-collaborative team as well as acclaimed advisors throughout the expertise in business, technology, as well as science, we aim to be the change for the food supply chain across decision nodes.
So all in all, Fresher transformed the supply chain with intelligent real-time system. We offer the proposition of the accuracy, the connectivity, and also the proficiency of the strategic decisions made for the storage, the system, and also the whole learning process. So here's where Fresher comes into with high impact value proposition strategy with compiling all the issues. We know that Fresher is not just building a mere sensor, but we are building the whole operating system to help distributed goods. So lastly, ensure your food with Fresher. Thank you.
I saw you have a slide on, how the whole process works with the hyperspectral imaging, right? Can you explain, how different is this from how, farmers, sell their produce? Does this slow down, the whole process? How is it different, and are there any things that, for example, farmers have to change? That's my first question. Second question, who's going to pay for a service? Is it the farmer, the transporter, or the retailer? And what's the kind of value that they get at the end of the day?
Okay, thank you so much for the question. For the first one, it is actually simplifying the whole process in terms of what happens in the status quo is that most farmers, as we mentioned before, they use the instinct, which of course have less accuracy. And even if they have the methods such as first in, first out, as well as like the visual spatial, they actually have like the error rate 40 to 60%. What we are actually providing is the accuracy rate with 98.6%. And what happened in the status quo is that data reports that 33% of the revenue is actually equivalent to the cost that is generated by the food waste, especially for the retailers. So that is for the first one. So we are actually trying to help on how we could minimize the waste by giving on the recommendation of the 3 strategic nodes that we mentioned before. Simply because what happened in the status quo is that most incumbents as well as competitors, they give information like the shelf life is 3 days away, etc. But they don't give insights in terms of what actionable recommendations or what actionable strategy that they could actually have. This is where we come to give like the best route, or in terms that if they have only 3 days, should they give it to distributor A, distributor B, or distributor C? And then the second one is on the storage box, as because we have the environmental sensor, and then the third one is on the dynamic pricing. And then
I would like to add about the flow of how it goes is that from it doesn't mean that all the wholesalers or the retailers have to have both sensors. Because as you can see, the hyperspectral imaging controls for the fruits and vegetables, and the thermal imaging controls for the meat, egg, or fish products. So if the wholesalers are focusing more on like fruits and veggies only, they can just go for the hyperspectral, but for the smart box, it is mandatory for all. And if for the environmental sensor, it's mandatory for the storage room also, because then we will get our data for us to pre-process and train, which we will display on our app also.
Lastly, about whether our solution will slow down the process, the answer is not, because usually farmers will check one by one for the food, but by changing the system into this system, they can increase the speed of the checking the food, also make it more accurate without making it too slow.
And then continuing on the second question, maybe we could move into the user persona, where what we're actually targeting is the high-end users in terms of retailers as well as the distributors, etc. Because what we see is that most of them, what happens in the status quo, as we mentioned again, that there is around like, based on the reports by the McKinsey, there is like 500 billion US dollars when it comes to like food waste, especially coming from retailers, and then by average it is around $70 million like annually. So it is actually like the big issue, especially for those like in big retailers. So as we mentioned about the economic values, etc. So even if, for example, if the company is valued at $500 million, for example, even if we just happening to having the points of 0.5% impact, for example, they will have like the baseline of $2 to $3 million. That is why our user persona is actually mostly on the big scale agribusiness as well as the chain executive. So those who are going to pay is actually the distributors to actually giving them like to the retailers on optimization of the value, because as we also mentioned, like the margin might be less. I mean, when we talk about the perishable food, that is why like the optimization of the quantity sold should be higher. That is what we're trying to protect in here. And then the second one on the retailer is actually, especially for those who have the value proposition on their quality, for example, they of course want to maintain the accuracy of the freshness as well as the shelf-life intelligence. Those are who are going to pay, as well as with our feature of dynamic pricing recommendation based on the historical data as well as with the demand and supply analysis.
So actually, I just want to clarify based on what Karen asked earlier in terms of who is actually paying. Maybe it's just for my benefit because I didn't catch that quite clearly. Are you saying that the retailers are paying or the farmers are paying?
Okay, thank you for your question. So the large-scale farmers, so the middlemen, like the distributors, and also the retailers, like the supermarkets, can use us, but not for the smaller scale ones, like the ones that actually do the farming.
So just to understand the basics, what you are saying is that in the large-scale distributor or people who have piles of food, you install this sensor, or you install this in retailer shops, right? And that then monitor automatically the status of the food and give you the result via the app. That's essentially.
Yes, because the feature is, we have like 3 features that we mentioned before. So when it is for the farmers, they could have like the recommendation on the routing as well as the storage, especially like for distributors.
I'm conscious of timing. I want to give you more chance to answer the question because if you answer yes for that, it's fine. A very basic thing, is it based on image recognition, right?
Yes.
If it's image, then I would imagine on a food factory, things are piled up. How do you even scan that?
Exactly. So in our prototype, it shows that we will use a conveyor belt. So it shows all of them in one layer, but not each of them are scanned. So they are scanned in bulk and they keep on going, and that's for one batch.
And this is integrated with the existing process? That's already what they are doing? Because if you want them to change the process of what they are, storing their food, it might be difficult.
Yeah, usually retailers have conveyor belt to check each of the food. However, the things that we change is instead of using human to check each of the food, we use the sensors, which is hyperspectral or thermal imaging.
So we just attach the cameras on top of their conveyor belt.
We're not really actually changing the behavior because the quality check has always been there. It's like having them more simplified as well as
You're
more
basically
accurate.
replacing human check.
Yes.
Oh yes, the human check.
So this is at the farmer level, right? Your conveyor belt is at the farmer level.
Farmer and retailers.
Okay, so it does a quality assessment from X gate at the farm. Typically there's 3, 5, sometimes even 7 intermediaries. The people in between the farmer and the retailer, right? Let's just say there's one, a distributor in between. So it leaves the farm, then it goes into the distributor, they repack it, then it gets stacked, put into cold storage, whatever it is, and then it ends up at cold storage here in Singapore. Do you do the check at the retail side again?
Actually, what is happening with the environmental sensor? So when they are actually in the storage box, as seen from the scheme, that is where the environment sensor will work. So it is no longer like scanning one by one, except like it is going to be rechecked on the retailer. So when it is on the storage box for distribution, that is where the environment sensor will work.
So when produce is packed, even if it's leafy greens, it's typically, even they're in bags, it's then boxed and then it goes into a bigger box, and then it gets palletized. So are you going to unpack and then sample one? And if so, what's your sample rate? Are you saying like 1 out of every 100 you will sample, or 1 out of a shipping container? Because we're just trying to validate, on the farm side we get it, because yes, you have singular products coming from the field, it will go through a conveyor belt, you can digitalize the scanning. Where the value of this is with the retailer, because you've talked earlier about being able to adjust pricing based on did it meet the logistic standards of 3 to 5 degrees. If it exceeded, then there's spoilage, right? So we adjust the price. So how do you just close that gap?
Right, so our training model actually uses historical data. So based on what's already been scanned like 1,000 times before, that's how we also got the accuracy of 98.6%. And this can also work with just one fruit or even a batch, so like 5 to 20 off the whole box. That can also give a prediction of the whole batch.
Okay, thanks.
Okay, thank you. We're now going to move to our lunch break. So we have 45 minutes. Feel free to go out, grab food, sit anywhere. You can bring food back in here, up to you. And we'll be back at 1:30. So enjoy.
Hello, hello. Can you hear me? Or? Yes? Okay, good.
No, I stepped down from that to stop. Because when I started something here, we had the operation, the world's first ISO certification around SAP Singapore Farm, and then the consumer brand. That allowed me to go from seed all the way to consumer, right? In 2018, one of our partners, a large lighting MNC, the productivity of their light from generation 1 to generation 2 went down 48%. So I had to go and solve these problems, and the fragmentation of the industry is why a lot of vertical farming and farming is failing, is because it's up to the farmer to go and choose all these parts, put it together, and then try to figure out what the intelligence is saying. So having done the whole vertical stack, and I created the world's first operating system for Sustainare in 2018, backed by Singapore government. The board wouldn't let me sell lights, right? Because it's a change of business model. We're a farmer, not a trader. I pushed it to them, and I said, look, we'll create a separate entity and name it something else. I'm not sharing the same resource with the farm, but greenhouses share a lot of the same components. So from an economy of scale standpoint, if I sell this to greenhouses, I can reduce the cost of our farms. And they went, too risky, change of business model, we don't want it. So I said, fine. And this is where I negotiated my step down as CEO. I didn't get an exit. I just stepped down as CEO, stayed on the board, worked with the team, and then. And so you're still today? No, I stepped away. The company has made a lot of moves that I wouldn't have made. Yeah. It's still out there. I mean, they've got this funny red logo now. I don't know. It was we were the first. We had the first full heavy raspberries, first industrial. I remember you mentioned your offices in London. Where was the room with all the lines? You know what I mean? Where is the office? So when I stepped down, the R&D lab, which we did that big launch with a few of the ministers, etc. So when I stepped down, we were moving the lab.
Amanda, do I have to point this that way or anywhere? No, anywhere. No. Can I try now? Yes. Cool.
I got a free office. So the change of business name. So
Hi, everyone. Welcome back from lunch. I hope you enjoyed, and we're going to kick off the last round of pitches. We have 3 more pitches for you with Sitzal.
All right, thank you. Okay, so it's afternoon, right after lunch, so hope you guys are still awake. But I'm going to give you a mental exercise. Picture an extension cord, like the bright orange one that you see here on the screen. Plug one end into that wall socket there. Walk out of the door, go downstairs, go to the entrance, keep walking, go through the neighborhood, walk across the city, go until you hit the ocean, then dive in. Drag that cable across the seafloor, the seabed, for 4,300 kilometers. Yeah, when you reach to the other side, you still have another 800 kilometers to go in a scorching desert. And sounds like a comedy sketch, but that's the premise of a real project that is now under construction. Ding, 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 sun cable. Yeah, so the idea is to generate a lot of solar energy in the Australian outback and physically pump it up to Singapore. It's going to cost $35 billion to build that infrastructure in another 10 years. So this is right now under construction and has been approved. Now, that's the best case scenario. Obviously, with mega infrastructure, that number is going to be generally much higher than that. And a lot can go wrong with the deep sea engineering. If someone drags an anchor 3,000 kilometers off the shore, you're not just going to send someone in a van to fix it, right? The whole thing shuts down. But what if this whole promise, the premise is overly complicated and there's a simpler solution that is right here? And actually from this room, you're already looking at solution. Thank you for choosing this venue. I mean, this makes it a more interactive presentation. What we plan to do with our new technology is to turn every skyscraper into a decentralized power plant without blocking this nice view that you have here. So we are a spin-out from UNSW, Sydney, Australia. And before I show you more about the product, we have to talk about something called the urban paradox. As cities grow, footprint of buildings shrink. So look at the rooftops here. They're tiny, and then you have the HVAC there, and you have the telecommunication towers. Very little usable rooftop to put solar on. But what if you're looking at the wrong surface? You have this right here, the facade, a lot of glass here. So, and this is very important because construction and operation of buildings, they account for 37% of the global emission. So they have to be part of the solution as well. So there is something called a building integrated PV, BIPV. That's a very rapidly growing market as it is, despite all of its limitations we'll come back to. It's very expensive, about $1,000 per square meter to install that. You have to modify the structure. You need to bring cranes, scaffolding. It's very disruptive. It's visually intrusive. It's going to block this whole view that you're going to pay a lot of rent for. And it's expensive. So what we do is a completely different approach. We have this see-through solar panel that you can just peel and stick, ultra thin, ultra light. You can put it on the inside. If you have very heavy glazing, you can put it on the outside. Doesn't need any unusual infrastructure. You can just use the same facade cleaning and washing platforms that is already there. Just install it. And I know you've heard a lot about, oh, the windows that generate electricity has been there for a while. A lot of them are gimmicks because the kind of energy that they produce is meaningless. We produce, on average, 100 kilowatt hour per square meter per year. And the number doesn't mean anything. That's roughly what you get from a rooftop solar, except that this is also transparent. So no cranes, no structural changes. And no ugly wirings will run down the facade. The wirings would be the very edges of the module will be connected to a combiner box, and from there to an inverter. The AC will flow right into the electrical panel of the floor. So why is this technology important? Why now? So BIPV, as it is, huge market, $250 billion by 2035. Retrofit is important because everybody's obsessed with this 2050 net zero. I don't know what's going to happen in 2050, but the fact is that 95% of the buildings that are going to be there in 2050, they're already here today. So you shouldn't wait for some futuristic city to solve all your climate problems. We have to fix the existing buildings. And that's where the retrofit revolution comes in. That's a huge market, $4 trillion with a T. And obviously, this is driven by all the regulations. You have probably heard of something called a Brown discount. So if a building is not energy efficient to run, it's going to fetch a lower rent in the leasing market. In New York, for example, there is something called a Local Law 97. Some buildings are literally illegal to operate because they do not meet certain energy standards. And then there's Googles and Amazons of the world. Everyone has a net zero pledge. So there's that push from the customers. And add to that, this recent whole buzz with the AI, every building is now going to have their own on-site computing needs that's very power hungry. So let's look at some numbers. In Australia, where we come from, for every square meter of this product, we can save, or let's say avoid, 80 kilograms of carbon dioxide every year. Looking at another example, taking a step back, in Shanghai, in the financial district, you have this iconic trio of buildings. Combined, they have 250,000 square meter of facade. That's a huge number. That's the size of 35 football field. So if you cover that with our product, we're going to generate 25 gigawatt hour of energy. Every year, that's enough to power a small town. And over the standard lifetime, which is 25 years, we're going to save 375,000 tons of carbon dioxide. Again, huge number. That's almost 0.7% of Singapore's annual emission. So at the end of the day, what is important is the money. So the Shanghai example, that's only going to cost about $100 million. Compare that to the 35 billion that we talked about earlier. And the other important number that you need to remember is this LCOE, levelized cost of energy. So for us, for our technology at cost, that's 10 cents. That's cheaper than any grid anywhere in any major city in the world. So no market is too cheap for us to go into. For installed price, we're aiming for average of $300 per square meter, significantly cheaper than what you get with BIPV, slightly higher than the premium that you pay for low-E glass. You have a great margin, and this helps us to have a variable pricing because in different geographies, you get different amounts of solar. The grid prices are different. Somewhere in Dubai, we might sell this for 200, Singapore 300, San Francisco for 400. So we start with the easiest, slowest hanging fruit. We go into buildings that are owner-operated, universities, hospital, governments. Second stream, we go into commercial buildings by partnering with utility companies. The third one, and the most scalable one, is to work with glass manufacturers. So this becomes a standard architectural solution. So next time when they're designing a building, instead of putting a passive low-E film, they just put this. So others have tried. You might have heard of organic PVs, which sounds very nice and farm to table. But if you have ever left your plastic chair 3 summers outside, you see that it completely degrades, and that's what happens to OPVs. And they also have their very low efficiency. Buzzword, perovskite, you have heard a lot about them. Just last night during the networking when I heard that, oh, did you guys hear about the active surfaces? Yes, perovskite. So my own PhD was on perovskites. Our lab at UNSW has the world record for perovskites. Very interesting technology. In the lab, it's unstable. It also contains lead, which is a heavy metal. You don't want to have it on your wall. You have something like cadmium telluride, company First Solar in the US. Rare elements, expensive, can be scaled. We have something that is affordable, high efficiency, transparent, non-toxic, all the good stuff. So the new technology is based on a completely new chemistry called antimony chalcogenide. It's 1,000 times thinner than silicon wafer. It's fully inorganic, so it just sits there and does its jobs for decades. And we can tune the transparency and the efficiency. So last year, we broke the world record for this type of technology, published in Nature Energy. This year, we hope to secure up to $1 million in non-dilutive funding, do a pilot. By 2028, we want to have a production facility capable of producing 50,000 square meters a year. By 2031, we're going to quadruple that and help our customers save 100 tons of carbon dioxide every single day. In order to achieve that, we have to move from the semiconductor mindset into construction mindset. A lot of semiconductor processes are based on vacuum, which is slow and expensive. We're already halfway done working on a Gen 2, which is going to be much cheaper and ambient inlight. It's like a money printing machine for solar. It's going to be 10 times faster for a production line capable of producing 100,000 square meters a year. That's only going to cost $2.5 million. So this is not a garage startup. We come from UNSW. UNSW invented the original solar set. The silicon solar set was invented at UNSW. And we hold world records for all the emerging solar tech. And we combine that with backgrounds in startup and business building. And then finally, remember the Sun Cable project. If that gets shut down, basically a whole country will be in darkness. If one window breaks, nothing happens. And that's the power of decentralized energy. We foresee that the future of energy is decentralized, it's democratic, and it's infinitely more resilient. If you want to share that future with us, let's talk. The vertical solar revolution starts today. Thank you. Yeah, so we are already in talks for pilots. We're relatively new, actually. We're as a company, we're 2 months old. But yeah, so one of the early customers for pilots is actually going to be UNSW itself throughout the campus. Yesterday, I had a very good meeting with BCA, Building and Construction Authority in Singapore. And yeah, so we're going to have potential to have some pilots here in Singapore this year. Yeah.
What's the origin of the technology? You say the company is only 2 months old, but how long did it take either you or your partners to develop this? and how much test this has been through?
Yeah, sure. We're a spin-out from UNSW, and so 90% of all the commercial silicon solar cell that are sold across the world, they're based on an architecture called PERC, which was developed at UNSW in the 90s. And I would say, like, I don't know, the top 10 solar company, all of their managements, they come from UNSW. So we have a long legacy of working on solar technology. And there are multiple new so-called thin film solar technology that are emerging, as perovskite, CZTS, CIGS, so on. For this particular application, antimony chalcogenide is the best one. That particular one has been in development in our group for about 7-8 years now. So yeah, and it's now pretty mature.
So basically, you are commercializing a IP that is developed by UNSW.
Yeah.
Right.
Yeah, yeah. So we're a spin-out, meaning that UNSW also has shares in the company. Yeah.
And okay, so basically they will take a share for the IP that they. And what's the relationship or what's the ownership of IP in regards with the company? Do you own it? You fully license it?
Yeah, yeah. So what happens is that you start with an option agreement, and there are certain milestones that we need to meet, and then that options will be turned into a license. Yeah.
Is it exclusive license?
It is an exclusive license.
Global exclusive license if you achieve certain milestones, though.
Correct.
What are those milestones?
Well, there are. Well, we have 4 milestones.
Or maybe the major ones you don't need to go through.
So the 2 technical and 2 like this commercial, like in terms of getting LOIs and getting some fundings, and also which we are on track with that. Yeah.
Okay.
No, thanks. Great pitch. You almost sold me. First of all, I noticed it's orange.
Yeah.
Not translucent then. So we're going to be looking through orange glasses?
So we have different tints, right. So there's a layer called the carrier extraction layer, and that can be a number of different materials. We have a neutral one, which is like a gray, like sunglasses. And then the orange one has a different material. So there's a range of color, I would say, like between grayish and to yellowish, orangish tint that we can achieve, yeah.
And then just curious also, I think your investment goes towards building one of these Gen 2 fabrication units. Correct. And that would then have a capacity for, let's say, 100,000. 100,000, which is approximately 1 building a year or so.
Yeah. So yeah, the idea is that this is an inline fabrication, so you can replicate it and increase the capacity. We want to be conservative with the numbers, but if it works the way we think it would work, it would be multiple lines, not one line. Yeah.
Can you share, the team composition of your company?
Sure. I mean, we are 3 co-founders. Professor Hao is a global known authority in the field of PVs, and also the leader of our research group. She is one of the co-founders. My CTO, Chen, he's the person who actually worked on this technology on his PhD and postdoc. And myself, I'm the CEO, so we are 3 co-founders. Yeah.
Is your $300 installation cost fully loaded, as in wiring, relays, everything?
Absolutely, yeah.
So your cost base is 100?
Yeah. So if you guys are interested, you can give me your email. We have a 100-page business plan, including breakdown of cost. Happy to share it with you.
So your business model is to sell solar panels, not power?
At the moment, it's solar panels, not
just
power.
selling solar panels. Yeah. What's the life cycle of these panels?
The life cycle. So we are essentially targeting for the same that you get from existing solar panels. So typically, what they guarantee is 25 years, and they maintain 90% of their performance. So we will match the same.
Mm. Can you paste these things to facades like that?
Yeah. So a lot of new, commercial glass, they already have the so-called low E, and which stops quite a bit of light, right? The near infrared and the UV. So, well, depends how much of the light is transmitted through. So if you already have a very heavy glazing, then you're losing a lot of the light. So we might.
Sorry, I was talking about the actual paneling outside. So it needs to actually go through the glass.
Right. Yeah, sure. Yeah.
Or can it sit on that?
Yeah, of course. Yeah. Yeah, so you mean the non-transparent part?
Non-transparent,
yeah. Of course, yeah. So we can develop actually a cheaper version of this, which is non-transparent.
So you can cover a complete facade. It doesn't just need to be glass.
Yeah.
So it's okay if it's yellow.
Yeah. Any color, right?
And you need to solve some wiring as well, because you need to go from window
Exactly,
to window.
yeah. So that's why we want to do the pilot, because a lot of the things we get from potential customers and pilot studies, for example, one just yesterday, BCA was talking about the adhesive. What if this peels away? I mean, we have a lot of rain and humidity. I'm like, good point. That's not part of the core tech, but something we definitely need to consider when we develop the product. Yeah.
Does it? I'm thinking about the feasibility. Does it actually work on large panels with glasses like this? Because typically on the solar panel, your wires are quite dense, right?
Yeah.
And that would not look good if you can see the wire on a glass panel. How do you resolve that?
Sure. So, so this is a different technology. I mean, I got asked this question: that silver shortage. Silver is getting expensive. Silicon solar panels use silver. Do we use silver? No. So there's something called the work function that essentially describes how the electrons jump from one material to another. Silver doesn't work for us. We have another material. It's primarily based on nickel. And it works in a different way. We have very fine lines that you wouldn't be able to see. You have to go very close to see it. Yeah.
So you can't, so basically you will look transparent.
Yeah, pretty much. Very, very fine lines, yeah. Like a hairline.
Maybe just a final question on sort of your pathway to commercialization. So you talk about pilots, you're now kind of approaching some of these industry-owned buildings. That's going to take, then you need to fabricate this at some sort of scale before you can implement this. How do you see this before this becomes a positive revenue generating business?
Sure. So I think the key risk is in that scale up, again, because a lot of the processes that we have, I mean, semiconductor is scalable with the same technologies are used to make this a screen. But this is scalable versus construction is scalable are two different scales. And we have a vision to cover every building with this. That's why we are going to that Gen 2, which is like ambient process and doesn't need vacuum. And yeah, so it's again, a lot of people talk about this, the chicken and egg type of thing, that you need to spend a lot of money into that production line, but if you do not have a commercial contract, and no one wants to invest in that. But anyway, at least in Australia, time is running out, we have a lot of grants that we were tapping into this year to develop those pilots and fabrication line and build trust with de-risk it basically for investors and customers, yeah.
Thank you.
Thank you so much.
Thank you. Next up is Veriflux.
Hello. Okay. Hello, everyone. I'm Vikas. I grew up in a small town near the Thar Desert of India, where having a cooling systems in a schools were considered to be a luxury because of a high cost. And when I came to Singapore, I was surprised by seeing that being such an advanced and efficient country, it spent 30% of its electricity to fulfill the cooling demand. And it is expected to rise by 66% by 2030. As the founding father of Singapore, Lee Kuan Yew said, cooling enables growth and productivity in Singapore. So cooling is important. We cannot cut on the cooling, but we can make it more efficient. That's why we are here. We are Veriflux. We make cooling system more efficient using our high heat capacity coolant. Today, in the traditional cooling technologies, they use a coolant that goes on the heat load, take a heat just by warming up, and that's the limitation. Due to warming, it's able to take limited amount of a heat, due to which, if we want to give a more cooling, we need to increase the chiller power, pump power, making a system inefficient. Today, all over the world, many researchers are trying to improve the efficiency of this cooling system, generally by upgrading the mechanical parts such as chiller, pumps, making more good like a heat exchanger. But very limited amount of the people or researchers are addressing the core problem, and that's the coolant itself. As a Veriflux, we have developed a patent-pending coolant technologies that can be integrated easily inside this cooling system with a minimal change. When we cool our coolant, it forms a micro-size, tiny reversible energy pocket of a cold energy. And when it goes on the heat load, it gives the cold energy and take a heat energy by warming and by melting effect. Melting effect you can take in such a way, like ice melt on a hot surface, and hot surface get cold. After taking a heat, my coolant become a clear solution, ready to recharge and regenerate with this tiny pocket of cold energy. And in this way, my coolant able to carry 5 times more heat energies compared to the traditional coolants. We have validated the cooling performance of our coolant technologies and validated that our coolant technology can save 21% of energy and provide the same cooling performance. We have validated on the 10 kilowatt prototype on a scale, and this was our first proof of concept in our lab. And the coolant physics already verified by the third parties, and we also have documented and published some of its results. If you are interested to know more about how I did it, more technical details, we can discuss of the PPT. Let me give you a customer's perspective with the help of mine. Thomas. He is the operator of medium 10 megawatt data center in Singapore. He spent on average 50 gigawatt hour of electricity. That cost him around 11 million of USD. And he lives in a country like Singapore, where the policies like a green data center pressurize him to make a data center more sustainable by reducing carbon emission and the water use. If we put our coolant and integrate it with the existing coolant technologies systems, he can save around more than 2 million USD on the OPEX of the cooling electricity. And he can avoid a 7 to 10 kiloton of carbon emission, and with some meaningful of water saving. And we have conducted more than 40 plus stakeholder interviews with the data centers, peoples, with the cooling system providers and peoples, and want to understand what actually they want to need, what's their need. And the answers were same and consistent. They want to have a higher efficiency for the end users like data centers, and they want to save on a capex also, and they do not want to much change in the existing cooling systems. And that's why, as a Veriflux, we win in this competitive landscape. We provide a high efficiency as well as the more high OPEX saving with the low capex. Today we are still doing a market investigations, and we have a pretty good idea like what kind of a checklist cooling system provider or the end user need before adopting our technologies. And accordingly, we will build a system-specific prototype, and that's why I'm here, to raise a fund to build this prototype. By the end of 2027, I'm looking to build my first paid pilot plant of 1 megawatt in a collaboration with the cooling unit manufacturers. And by 2028, I'm looking to enter in the market. As a Veriflux, our go-to-market strategy is this way. We will sell our coolant and controller to the cooling unit manufacturers so they can have a benefit of a smaller chiller, smaller pump, and they can save on OPEX. Whereas second benefit they can have is that they can sell as a differentiated product in the whole market. And end user can have a benefit of efficient cooling. And we will also sell our service and maintenance fee to the end users. And our product can be applied to various sectors in the market. It can be a data centers, district cooling, industrial cooling. For a moment, we are choosing data center, our beachhead market. And we are targeting upcoming new 700 megawatt data center on a Jurong Island in Singapore. And accordingly, our SOM become 66 million, and we have a potential to avoid half a million ton of carbon emission. We think our business is scalable. We are already in touch with the 6+ cooling unit manufacturers, and one of the cooling unit manufacturer already asked for our coolant technology to test in his workshop to evaluate it further. And with the help of them, we are looking that we will capture the 30% by 30% of 700 megawatt and apply our coolant technology on the facility side of the data centers, and will generate a cumulative revenue of 20 million by 2030. And at a moment, my next 2-year targets are like, we are going to build a prototype and the paid pilot. We mainly need a skill of more on the technical side, I would say, and that's why our team have these kind of skills. We can optimize the coolant technology, we can scale it up, we can de-risk it, and we are also supported by our business advisor who will help us to do the system integrations and design for the end users. And last, I would say, I will close in this way that we are very flux. Greener, cooler, smarter, the future of cooling. And I want to make a cooling system more efficient. For me, it's a personal. I want to make sure that cooling become affordable back in my town and everywhere all over the world, so that they can also have a growth like Singapore. And I also want to make my technology more available to our data centers and these kind of entities, so that they can have they can become more sustainable. And lastly, I'm here to raise a fund to build a prototype. And now the question is from you guys. Are you with me in this journey? If your answer is yes, please connect me after this PPT. Thank you.
Can you run me through the technology behind? Because you said that, it's supposed to be a cooling solution. Is it supposed to fully replace chiller solution, or is it a complementary? And in data center, the cooling technology is also slightly different. So how does it complement or replace the existing cooling system in different industries?
Okay. First of all, it will not replace the whole cooling system. In a cooling system, it will replace the coolant. Today they use a water or water glycol mixture, PG25. First of all, that will be replaced. Secondly, there will be an additional technology box. Mine will come inside a loop. That's we call as a very flex controller. These are the two things we need to add. Yeah, that's the one. And yeah, there was a question of the chiller also and pumps also. As our coolant carry more energy, like 5 times more energy than a comparative existing coolants. So you need to pump less. You need less chiller power because of a higher coefficient of a performance. So your pump size decrease, your chiller size will decrease. So they have a compact size of the unit with the same cooling performance.
So basically, you're using a different coolant for your chiller.
Yeah.
And this is something that you might want to work with the existing chiller OEM to get their buy-in, so that they could potentially incorporate your solution to.
Yes, actually, during my market interview, I understand that data center will not buy from me directly because reliability is so high. That was one of the takes. Then they have suggested me that why I don't work with the cooling unit manufacturers. And I went to them, and they were happy to see my technologies. And they already asked me, let's integrate. And that's my also a business model. I will go via them. They already are a reliable partner and trustable partner for the end users. If they're able to trust me, integrate my technology, yes, end user will adopt it.
So then the other question I have is, what is the uniqueness of your technology? Is it just, what's the uniqueness of your technology? Is it just the coolant mix, or there's more to it? How defensible is it? How easy is for the other OEM companies to copy what you do?
Okay. First of all, it's the patent pending technology. Patent is on the how we make a coolant plus how we generate the coolant. That's the patent. But our moat is not only the IP. We are more than this one. We know that how we gonna control the size of these tiny particles of the pocket of the cold energies. How big we can, at what temperature you want to melt it. We can melt at a 27 degrees also. We can melt as a 15 degree also. It's customer specific. These are our mode. And lastly, I would say that they don't know how to integrate at a system level. We have that knowledge. These processes make them difficult for them to copy our technology. And at last, we will be selling separately our coolant and the controller box. Yeah.
When a cooling system manufacturer look at the selection of coolant, what are the KPIs they look at?
Can you please repeat it?
No, I mean for your customers, right? Your customers are cooling system manufacturer.
Yes.
They integrate your coolant.
Yes.
So when they select the coolant supplier, what are the key, aspects that they need to consider? Cost, durability, scale? I don't know. I'm asking you. Yeah.
Okay.
Yeah.
So what I understand is that you are asking that what are the checklist my cooling unit manufacturer want to look. Definitely it's one of the capex, how much money I save, how much electricity I save. On top of that, there are different things also, like compatibility, how compatible my coolant it is. Compatibility, if I go into more detail, is a corrosive nature, if more technically, there is a biofouling, there is the scaling effect, these kind of things. On top of that, there are a few more things. Repetition, how, like, if I repeat 10,000 cycles of my coolant, will it be stable or not? How thermal stable it is? Though, partially we have de-risked it, this part, but yet we need to give a system specific, like coolant unit, though I already proven my coolant physics on this prototype, but this gives us that coolant will work. But how well it was work on the cooling unit, manufacturer unit, that they want to check.
So typically, how long does it take a cooling system manufacturer to onboard a new coolant supplier? What's the testing period?
What I understand, you want timelines, how quickly they will adopt my solution.
Yeah. What's the industry standard?
Okay, so generally they look in the compatibility, like if we able to show that pumping power is reduced, chiller power is reduced, that one. And next they look for a 3 to 4 month run inside a loop. With that one, they also test that they measure conductivity, they measure the pH levels continuously, like every 2 weeks, one reading, every 2 weeks, one reading. Accordingly, they will decide after that one. That's the things they want to test.
So about 6 months, 3 to 4 months. Okay.
Yeah.
Can you talk me through the financials? You've got 75K upfront per megawatt, then 20K recurring.
I believe this one, you want to know more finance.
On the finance side, so for the user, how much are they saving?
Okay, I have did the calculations. I have a pretty rough estimation. For a per megawatt of a heat removal, cooling unit manufacturer have a benefit of 115,000 USD, and we are charging them a 75,000 for a coolant plus controller box. So they have a net benefit of a 45K also. But these are based on whatever the insight I got from them. Yeah. And end users, they can have a benefit of per megawatt of like a data center to 40K USD per megawatt of a heat removal. And we are charging a 20K servicing annual fee for them.
You talked about the corrosive nature of a lot of these coolants. So how long do you need to have like a POC in operations before some of these OEMs are going to say, we're satisfied that this doesn't corrode the seals, the pipes?
Can you please repeat?
The corrosion of a lot of
Yes.
coolants.
Yeah.
Yeah. So how long do you need to have a proof of concept?
Yes.
In operations, not in your lab.
Yes.
Right?
So I have an answer for that one also. Actually, we did it. Somehow it's not here in the backup slide, but I prepared it. So yes, it have a corrosion properties, but today they use water and PG25. They also corrode the current systems. The difference is that they use an inhibitor to level down the corrosion levels. And with that inhibitor, we have tested my coolant, the corrosion level decreased by 97%. And it's come to a level of 1 to 10 micron. That's generally used today in the industry.
I think the question is also, which I also have in my mind, is how long do you need to demonstrate this in your pilot? You want to build a pilot for 100,000? This setup
Yes,
that you showed on the slides?
Yes.
How long do you need to run this to demonstrate or
3
give
to 4 months.
confidence to the
Actually,
users?
It's a 3 to 4 month. I need a run demonstration. I need to show them to the cooling unit manufacturer and the end users also.
How often on a HVAC system would they typically change out the seals, for example?
Can you please repeat?
So we're talking about how corrosive
Yeah.
the coolant is.
Yeah.
3-4 months, I'm assuming that every 3-4 months they're not replacing a seal,
No,
right?
no. We don't need to replace a coolant. That's the thing. Once you fill it, once you put an inhibitor, you can run to more than a 5 year easily. No need to replace a coolant. In a data center, they use a PG25, plus with water, plus with inhibitor, and they run for a 20 plus year. It's a one-time fill only.
Accelerated, so it's 4 months testing.
There will always be some
You test the
leakage
pH
of the coolant, refrigerant leakage, and you have to. There will be leakage, refrigerant leakage in chiller plant, and I suppose you do have to replace it from time to time.
Yeah, that's yeah. I agree with your point. There might be a mechanical or a failure from a man's side or from a human's error. There might be a leakage. At that moment, we need to refill it. Okay, thank you. Thank you.
Thank you. And for our last startup of the day, Wiedenbaron Plus. Welcome.
Could you guys hear me? Yeah. Okay. So you may not heard of it before, but Thailand is the second largest automotive rubber manufacturers in the world. So we from that industry. And what we could see is a high quality, rich in properties rubbers throwing to recycle. 82% of it goes to recycle, but it's transformed into a low value product. And on the other hand, there's another industry that's craving for that kind of property, and that industry is construction industry. So what about we turn one waste into another one treasure? And this is our stories. So we come up with an insulation system with our 3 goals to tackle the problems. We have to reduce energy, we have to reduce waste, and we have to make it cost efficient in the long run, both for manufacturers and end client. And that's how we come up with the product, vulcanized insulation membrane. You could call it VIM. So VIM is a pre-consumption automotive rubber waste that transform into a highly performing building materials. And the cost saving of it, if you use regular rubber like synthetic rubbers, this thing would cut in cost at 96.2% already. And our product is all about, when it comes to construction, it's all about respond to what industry really need. So we call it, first thing first about our product, we call it 3P. Our product is waterproof, heat-proof, soundproof. And beside that, we designed it to make it consist of no harmful compounds in it, alongside with lightweight. We want to create logistic convenience for people, and we're still using the old method of construction to install this thing. So it's easy and convenient for installer to adapt to using our product. And let me formally introduce myself. My name is Kongpat Paibunakunkit. You could call me Kevin. Well, I'm an architect that I have a background in German engineering. And alongside with, right now I'm working as a green bean consultant of International Finance Corporation of the World Bank. And alongside here is my partner, Napat Parapat. She's a polymer expert. Alongside with that, she is a major shareholder of a rubber manufacturing company. And before she became a polymer expert, she used to be a venture builder, helping startups in Southeast Asia create a stronger ecosystem. And we're not alone. We come with board of advisory that ranging expertise in architecture, green finance, system engineering, and even civil engineering, all of them from renowned University of Thailand. And why something like VIM never happened before? Well, I have to say this. Because it's not easy to make something like industrial waste into a proper product. You have to deal with delivery waterproofing, sound attenuation, thermal property. You have to deal with maintain elasticity for long term. You have to reduce it some harmful compound like polyachromatic hydrocarbon or volatile organic compound to a building safe level, which is very difficult. And most important of all, it's about cost efficiencies and feasibility in scale. So this is two technologies that make Vim truly different from other. The first thing first, we make it with molecular design, and the second thing is about our processing technology. So in terms of molecular design, we are working to the molecular scale of this product. We're working by adding two compounds that I could tell you is zinc resinolate and organic peroxide. How does it help? Basically, it eliminates odors that come from the rubber itself. It eliminates harmful compounds, so say no more to PAH and VOC. And most important of all, this molecular structures is helping to holding structure together, so it's offer a better performance of the membrane. And we can't just think about the product side alone. We have to think about how it's going to be manufacturing. Our technology is low heat treatment lie in our facility itself. We cut 45% of the initial energy and 40% of the cycling power. So we could operate our production in the long run and still be competitive in terms of like cutting down energy in our manufacturing process. And of course, what is the first thing that comes to concern when you talk about construction materials? It's about safety. This thing gonna live with people in the same built environment as you. So I gotta say that we went on rigorous testing, ranging from university, rubber institution, private companies, and even testing it in-house. We make sure that our product has no harmful compound, yet we also fire retardant. So when this thing is next to the fire, it got char, but never fire spreading. And alongside with that, it's about climate impact as well. And I think vulcanized rubber is one of the most carbon-intensive rubber that we are dealing in automotive industry. But the unique thing is, when we transition it from the end-of-life product into something new that is in the building sectors, we're talking about longer time for life cycle assessment. We are dealing with 2.4 kilogram per 1 kilogram of materials in the new industry. So 100 square meters of our product is equivalent, just embodied carbon alone, equivalent to planting 55 trees a year. That's how I would portray it. And in terms of economic impact-wise, you could think that right now we are dealing with a rubber scrap worth $80 per ton. The kind that you go and sprinkle it in football field, the kind that you use it to do pyrolysis and turn it into bitumen. Well, say no more to that with the cheap materials. We could transform it into construction material that was $2,400 per ton. We talk about 25 times more value that we could bring back to economy. And beside that, we got some piloting project, and this is what we're proud of because this is the first project that we got. 200 square meters of Vim has been installed in this house on the roofing area, in the ceiling. The thing is, it only takes one installer to install 200 square meters in 2 hours. So that is quick adaptation, easily to install, and convenient to establish. And it's not just about how fast we could do it, it's about how much performance we could provide. Our product is highly well in terms of decreasing temperature differences. We could bring the temperature down 4 to 8 degrees Celsius. And 4 to 8 degrees Celsius is come from the principle of the material itself. We have high thermal surface resistance and a low thermal conductivity. So we help block radiation from the sun, and we help block the heat by conduction. And right now, we got more than 10 projects anticipating incorporating Vim into that pipeline, ranging from hotel, hospitalities, temple, landmark, commercial project, even private residents are willing to working on this project with us. We could aim that right in this year, we could expect more than 10,000 square meters of Vim being installed and changing the city from the ground up. And in terms of our business model, we are B2B and also B2C as well. So basically, we are looking for partners. We're selling our product to our partners who in technical cooperation. We are working with some metro distribution, material prefabricators, and even building firm company. So, but our goal is we want to provide benefit for all of these stakeholders. When it comes to partners that are working on tech co-op with us, we're providing new materials, new property for them to explore new product line. When it comes to our contractor, we are lower the cost margin and higher profit margin for them. And for end client, we are offering a better performing building, better performing materials for them. And this is what we're also proud of as well. Right now, we are working on technical cooperation between two innovations. So we are working with Japan, Sweden, and Thailand to create an innovation like this. One of them is a reflective film from Japan that we are working on as one layer to solve that problem that they can't install on other but metallic surface. For the Sweden innovation, we are working with ceramic coating and gable room roof to help us damping sound factors that could lose attention of the vibration when it comes to impact of the weather. And the installation, I call it new materials or method versatile application. Because we offer the same method to installing membrane. If you are an installer, you're going to use the same primer, same adhesive, same equipment you have been used before. So it's an ease of mind for them. And we already translate our manual into 12 languages just for international project that's going to be upcoming soon. And right now, pipeline has been executed for piloting, collaboration, and right now it's about scale optimizing and how we could work on AI-driven because we want to see the result as tangible as possible. So we want to integrate to detect energy loss and thermal inefficiency in the future. Right now, we work with two universities for that. And well, I think this is the time to make this possible for the sake of industrial waste and material innovation. Thank you.
What's the price of this material compared to traditional insulation material?
Well, that's the thing. Because I would position our product to be waterproof membrane. Because insulation is cheap. When you heard the word insulation, you go with cheap. So we go with membrane. But unlike other membrane, our product is waterproofing and also heat-proof. But in terms of pricing, I would go that, well, in the market right now, people are selling this kind of product, waterproof product, at $30 plus, more than $30. And it could ranging to epoxy that would go for $60. So here's the thing. Right now, we are price competitive. We are at the lower end of the pricing when it's come to waterproof membrane. So approximately $9.
Sorry, I'm trying to understand. So you're saying that you are replacing waterproof membrane?
Yes, because we are waterproof membrane.
Okay. And waterproof membrane is around $30 to $60.
Exactly.
And you are $9.
Yes.
So you are much lower than the traditional.
Exactly.
And waterproof membrane is a necessary building material?
It is.
Okay.
Well, if you look outside, you're going to see so many flat roofs across Singapore. Okay. Because it does need this kind of waterproof membrane at the top. Whether it's going to be bituminous, whether it's going to be epoxy, you still need it. And right now, I would say that in terms of the market, it's expand. $1 trillion of construction materials, 48.5% belong to insulation and roofing. And roofing, part of it is about this waterproof membrane. So we are in a very high value market segment of construction.
What's the fire rating for this material?
Sorry?
The fire rating.
Fire rating. So we done tested in houses. We are fire retardant. I could tell you that it's fire retardant. So when it's, as I mentioned, when it's gotten fire, it's not spreading. So I think that you might see some cases in Hong Kong earlier this year where the green mesh is like burn entire building up. That is something that is not fire retardant. So when fire hit us, you burn it. It's like it's gonna drop on the ground.
But I guess the question is probably more around certification.
Exactly. Yeah. We do testing in terms of certification as well, but I don't remember the exact rating of it.
Have you checked with any, like BCA, for example, if this would be, because I've seen the examples you've provided, you've used it as a thermal material in the sealing void, right there.
Right.
So is this going to become a problem from a legislation standpoint?
No, not at all, sir. We do have certification to cover it.
When you are selling at what seems to be a very attractive price, right? $9 versus 30.
Well, that is attractive.
Yeah. But what is your margin?
The margin.
Yeah.
We get about, the cost of making this is fairly well competitive as well. So I would say about 50 to 80%.
Gross margin. Okay.
And just a question as well. I've got two questions. One is indeed on the cost of your source materials, right? Because in my experience, recycled materials do take a lot of effort, energy, and cost to be, let's say, upgraded and processed, and often rely on subsidies. So I would like to understand your fabrication process and the dependency on, for example, your supply chain or even on dependency on subsidies, government initiatives to make reusable materials available. That's one. And the other one is back to sort of the use of this, because you show housing which are actually tile-based, so they don't need waterproofing. So the alternative could actually just be your existing low-cost insulation materials.
Mm-hmm.
So the application is maybe only for flat roof type surfaces, where you can then also get the benefit of the membrane. So I just want to understand if you haven't overstated your sort of market applicability.
Well, that's interesting. Well, the first question, I would say that our materials is pre-consumption waste, as I mentioned here in the slide. It's pre-consumption waste. So basically, we got the product from the additional process of the factories. So when the rubber, automotive rubber is being made, you got scrap rubber from it. So that's how, so we use all that extensive part that we get from each molding process to make it to bring it back to production. So relatively, we're not like paying more cost. We're saving cost from it.
Excuse me,
right
can
now,
I jump in? Can you hear me?
Oh, that's my partner.
Sorry. Yeah, I would like to answer the questions in terms of the supply. So because we are having a partner in the manufacturing, so right now we have a waste of around 200 tons per month in our internal facility. So for the first piloting projects or first few years of doing the business, we believe that we will be able to use our internal resources for this. And later on, we are partnering with energy conglomerates here in Thailand, so they will be able to supply us for raw materials. Sorry for making everyone.
Thank you so much, Nam.
Right.
All right. And the second question is on the application. Flip the paper to the back. That is the part of the building that waterproof membrane could be part of it. We're talking with many conglomerates across the world, Japan, in Thailand. This kind of product could apply then more than just roofing. It could apply in landscape.
Is it food safe?
Sorry?
Food safe.
Well, I would say that you could lick it without getting sick.
Yeah, but can you store water for an extended period of time in the elements and it not leach anything into the water?
Yeah, that's fine, yeah. In that department.
Because you got water tanks here, so it's
not, yeah.
Okay.
So do you have a need then IP on this product? Are there ISO certifications for some of these quality control questions that have been raised?
Quality control, we do have it, yes. And in terms of intellectual property, we are applying for 2 IP right now. So one of them is about the manufacturing process, and another one is method on how we do it. On the specific formulation, we plan not to patent it, so it's already like trade secret that only 3 people in the world knows it. Just to make sure that the formula is not leaked out, and we don't have to do on IP control that much.
And the source of that IP is developed by your partner?
Sorry? Oh, yes,
IP.
developed by my partner, yes.
Okay. And how long did it take to develop it?
I think we know the method already. We are developed the drafting. One of them has been sent to, the APO, which is the intellectual
I guess
property.
what I'm trying to understand is the barrier of this technology. How long does it take for someone to develop it, and how much does it cost to develop it?
I mean, like from the experience that we have been working with rubber, to be honest, like we got a manufacturing team that's been working on it for 35 years. Like we do have precise understanding of how formulation is going to be, how the process is going to be. Right now, it's just like a proper establishment of intellectual property that should have been done a long time ago.
Okay, thank you.
Thank you so much. We'll now move into the keynote speaker. But in the meantime, I will ask our judges to please meet me outside because we'll go and start deliberating. But please enjoy. Danny will be up to introduce the speaker.
All right, awesome. Now I'd like to welcome to the stage Prof. Theodore Cojoiano. He is an associate professor here in sustainable finance. He's going to share some insights and some anecdotes into the financing side of this world. So thank you very much, Prof. Theo.
Hi, good afternoon, everyone, and really a warm welcome to SMU, to so many teams. I hope you've had a great time pitching. I've heard a few of you today, and you are all amazing and fantastic. It's really a great pleasure for me to speak to you today. And just big thanks to Ronnie and James, but also to Danny and May for thinking of me. I really think you have a wonderful initiative, and looking at the big picture of the MIT CEP initiative is amazing how you're managing to kind of pull up at least, I think, 3 heats from all around the world and converging into the Boston finals. And yeah, how impressive. I think today there are startups from Australia, Azerbaijan, India, Indonesia, right? Singapore, Thailand. I hope I'm not missing anyone, right? So that's amazing. Now, okay, I must confess something, okay? So when I got the invitation to speak to you today, to really creative, capable, motivated entrepreneurs like you, I had a slight hesitation in accepting. I thought, you wanted to hear from established clean tech entrepreneurs who, basically made it, right? They were able to tell you all about their war stories, how they even maybe exited the business if they didn't dilute too much, right, in the fundraising process. But then I thought there could be something of value that I could share with you today. And that could be probably about my experience fundraising about 20 million for R&D, climate analytics, but also working on sustainable finance policy. So I know you don't get the clean tech entrepreneur that you admire, but let me ask you this question. Who do you think oil tycoons admire? Anyone? Who's that? The shareholder. The shareholder. Very likely. Here's one suggestion. Maybe the famous painter Picasso, because it was only he who could sell oil so expensively. So, maybe it does come down to the shareholder. So let me tell you a bit about my connection to energy so you understand a bit more the person. It says Prof in Sustainable Finance, but it starts from a very, very early age, this connection with the energy sector. So my father was an electrical engineer, and he would be on some of these cargo ships that dock into Singapore or Boston or Amsterdam, and he would fix like the whole kind of engine of these like mammoth cargo ships. And when he came back from one of his voyages, I think I was just a few years old, and I still remember that story, overhearing it. He was telling my mom that they were stranded at sea and the food supplies were going low. So technically, the chefs started doing some food rationing for the crew so that they make it to the next port and everyone has enough food. But what happened is, just after midnight, he went to the kitchen and he saw one of the chefs kind of taking away at some of the rations. So basically, for lack of better words, he was, stuffing his face with the crew's food. So my dad asked him, it's like, hey, can you please share some of this food? And the chef said, I'm a chef, I get to eat the food. You're an electrical engineer, you eat light bulbs. Yeah, it was pretty harsh, and I still remember this story. I was like, oh, wow. For a long time, since I was a kid till a baby, up to my teens, I thought, I need to be a chef, not an electrical engineer. This is no good in case of a crisis. But, that didn't deter me. I ended up doing a 5-year degree in electrical engineering at Edinburgh. But let me tell you my realization. I know today you were pitching all about product, and you were all about product and all about how I can make customers happy. And let me try to challenge a bit the view on how you could also think about outside of the customer. And I know you need to be customer obsessed and kind of go all the way, and I get that. But the reality is that when we're trying to solve for climate change, for pollution prevention, for circularity, many of the applications today, for the built environment, it is also the policy landscape and the many, actually, industries that profit from not being sustainable, okay? And it's really important to get to understand the politics around the industry that you're in, the whole industry value chain, and position yourselves in the best light to really win this. This is one of the reasons why I kind of quit tech, so to speak. I still can't change the light bulbs. I'm a wannabe engineer, okay? And then kind of moved to data science and sustainable finance. So, look, we're just more than 10 years past the Paris Agreement, and we still haven't managed, right, to reduce emissions meaningfully worldwide. What's more, AI and data centers, we just had a startup, right, talking about data centers, are really increasing our energy footprint, and with that, right, our climate footprint. So it's true, though, that in many countries, new renewable capacity really overtook new fossil fuel capacity. I think it's like 90% to 10% around the world at this stage. But what we're doing is we're only meeting this additional demand capacity that we really need. We're not really replacing the legacy infrastructure, which I kind of sense some of you are also trying to really disrupt at large scale. So in many countries still, the process of industrialization remains a major issue, and we're losing forests, right, due to agri-food and agricultural systems. And we've raised 5 trillion in debt. So, okay, financial markets have claimed that in the past 5 years, we raised about 5 trillion, so about 1 trillion a year that we call green. But again, we don't seem to be making a dent into solving the issue. So as you look to scale your startups and be part of the solution, I want to give you just 2 reference points. I won't bore you much with a lot of things, but just 2 reference points that I would like you to reflect on sustainable finance, and the other point is on conflicts of interest, okay? Because I've seen policies, startups, and many things that I was trying to do that failed just because the people at the table were just not coming from the right environment that would be conducive to an environmental solution scaling. So we're going to reflect about that in a moment. Let me tell you how traditional environmental policies are set up and just contrast them a bit with sustainable finance policies. So traditional environmental policies, right, carbon taxes, trading schemes, so they haven't had enough public support, right, from politicians to really scale around the world. That's why the COPs are not working. So we don't really have that level playing field between green technologies and more polluting technologies. We've built the more polluting technologies based on a heavily subsidized system, which we haven't phased out, right? And now we're having these debates about which industry we should subsidize when, of course, it's not a level playing field. The other thing that I want you to reflect on is that society tolerates significant harm to the atmosphere, to nature, to our river system, so on. So we tolerate it, okay? Many things are legal, right? Coal power is legal. Okay, we do it for development purposes, right? We are, again, putting emissions, we're putting heavy pollutants into water. I know there's one startup that is looking to solve that, right? You're, I think, solving the affluents from agri-food systems. So all of that is done under a legal framework that says, go ahead. My favorite one is BHP Billiton. So where's the Aussie crew today? Yes, there we go. Hello, hi. So BHP Billiton, on their website, they would say, we will not mine in protected areas. We will stay away from them. And then you have this footnote in the annual report that says, unless it is legal, which means, in essence, a company would, again, go with the legal baseline anytime. They would choose the legal baseline, and there's this thing that governments can use to bypass any environmental legislation, which is called overriding public interest, which means if we're going to make more money, then, you know, even think about this externality or factoring in whatever environmental problem you're trying to solve. We're going to go for it, and we're going to call it overriding public interest. We want to develop, right? We want the materials in the subsoil. And so how do sustainable finance policies work differently, and what's really new about them? So sustainable finance policies work a bit differently because the kind of raison d'etre or rationale for them is a bit different. So after the Paris Agreement, you had many investors, maybe some of the judges here, who knows, we need to check them out, they're selling green financial products, right? So they would go to asset owners and fundraise a lot of the asset managers and say, the pension funds, and say, we want to deploy capital in a way that is meaningful and in a way that is green. Now, this begs the question, what is green, and what are you selling as a financial product? Is that making a really meaningful, substantial contribution to the problem that you're stating to solve? And that means that the benchmark is very different. The benchmark is not economic development. The benchmark is you have a financial product that says it's doing X, and we need to be able to benchmark that it's really doing X. It's not Y, and you have a scientific benchmark to measure that substantial contribution to the environment. And this is where green taxonomies come into play. Has anyone heard of green finance taxonomies, either in your own country or other countries? Any hands up, down? I see a few nods, yeah? Okay, maybe 3 nods, yeah, some cool nods. Okay, no hands up, but cool nods. So basically, these green taxonomies, if I can tell you a bit about them, they're data dictionaries that take every single economic activity in the economy and try to judge whether they're making a substantial contribution to a particular environmental objective. So for example, solar energy. Good for climate? Yay, good. Why is that? Well, if you look at the LCA, and I've seen a lot of people having slides up showing nice low carbon assessments, if you take the LCA, beats coal, gas anytime, right? Under 100 grams of CO2e per kilowatt hour. So solar is probably a no-brainer. You can do the same with steel. You can say, okay, what are my clinker emissions? You can take literally every single economic activity. What is a green building? What is an actual meaningful retrofit? We were talking about retrofitting just now. You can build these benchmarks deeply into these sustainable finance taxonomies. And these become the basis of green bond issuances. So if you have a company saying, I really want to meaningfully transition and deploy CapEx, and keep in mind this word, it's really important, CapEx, then I can use this green dictionary to really legitimize my issuance and really be sure that it is a green product. And then on top of it, you can build a whole industry called, of course, the green finance industry. So why am I saying this, and how I think it might be relevant for you? I think you could use these taxonomies as a signal into your ideal, partial, let's say, customer base that you could pursue. The reason I'm saying this is because, again, the benchmark for a company that issues a green bond that is aligned to this taxonomy, i.e. promises that they will meet these best-in-class performance requirements, and they could be on climate, pollution, nature, water, adaptation. There's 5 environmental objectives, which, by the way, apply to Singapore at the moment. Thailand has a taxonomy. Indonesia has one. India is working on one. Australia, you guys have one since December, 2 years before, I think, yes. So basically each country that has a sustainable finance industry, minus US and UK, but I won't get into the reasons why, okay, has issued this guidance from the government that has these ambitious thresholds and guides these issuers. And what I'm thinking from an entrepreneurship perspective, these issuers that are aligning themselves with these standards, and they're putting their lifelines with their KPIs for their bond issuance, could be some of your customers if you can articulate and have a look to say, here's how my technology helps you to meet your green bond KPIs. Because if you don't meet your green bond KPIs, you have very different type of consequences. The investors look at you, particularly those European investors from which we see a lot of demand for green financial products, then, hey, you're not meeting baseline legislation, which, by the way, as we've discussed, is mostly not exciting and not ambitious. So I think you can use these taxonomies strategically. The other thing that, if I can reflect on the innovation of taxonomies and how they relate to companies. Now, we were talking about buildings, right? Well, every company has a building, technically. You don't have to be in the real estate sector to just use the technology you've just described. So that means that, for example, retrofit is something that applies across all industries or companies that happen to have a building. And what happens with taxonomies is they allow you to slice and dice every company into the very deep economic activities and allow you to understand how sustainable they are. So basically, if I say how sustainable you are on the green building performance criteria, then any company can use it as long as they have green building and they want to kind of demonstrate that. It's the same for renewable energy. You don't have to be a utility, right, to put solar. I mean, many manufacturing sites put solar. We have a technology, right, that uses, I think, is it SID Solar? SID? You guys, right. Is it also from Sydney? Yeah, Sydney, okay. It's the SID, right, in it. Okay. So basically, you are renewable energy generation, right? What you need to prove under the taxonomy is that your life cycle emissions from your product is less than 100 grams CO2e per kilowatt hour produced. And that's you declared green, right? Like most solar, for example, even the large scale one. You have the same benchmark. So, and anyone can do that, right? Anyone can be a renewable energy generator. It doesn't matter if you're a mining company or an electricity company or just a real estate developer. You can, again, put it in your building. And these taxonomies allow you to understand your sustainability in very kind of niche, self-contained buckets, which I think are ideal from a startup perspective, because then you can see exactly how you can fit in, right? Instead of saying, here's your big company, scope 1, 2, and 3 emissions, we're going to reduce that for you that much. You can say, you're this big company, you have multiple businesses. In this business, I'm going to help you meet your KPI. And that's a much nicer, more scientific type of discussion that these taxonomies allow you to undertake. So if you're interested in these types of data tools, we developed a tool for about 11 countries. We're going to have over 60 countries now. Tool is called sustainabletaxonomymapper.org. We can send it to you after, I suppose, you find out the results, and probably you'll be home. We developed it here at SMU. We're also working with our CFO office, who issued a 250 million bond. So the university, we're trying to incorporate that, and maybe, who knows, the university might be one of the first adopters of the tool in Singapore and allow for entrepreneurs to come to contract and show how, you know, they could help the university or other issuers with your technologies to meet these KPIs. So now, another reflection I have two more, and I promise I am done if the judges are coming back. Um, I know I've talked a lot about the substantial contribution to the environment, and this is the basis of the taxonomy, right? But things have changed a lot, and since I've come to Asia, coming from Europe, I got this like really hit in the face with the pragmatism of this part of the world. And people are genuinely interested about making a difference to the environment, but no one is willing to pay or subsidize the system from a commercial perspective. So having a top-notch environmental story is key, but you cannot give up on your kind of profitability and the actual business plan. Since I've come here, the debate is very different from Europe, where in principle people would like to scale these, but then even in Europe, we are faced with the fact that we have deindustrialized a lot, and now we're seeing a lot of, for example, EVs from China. And we see a lot of different products from Asia, and people are going, ooh, how about the jobs? And the reality is financial markets won't deliver your green technologies unless you have a good subsidy system behind them, okay? So I'm not saying the markets and the bonds will solve everything, but really, if you can articulate both cutting edge environmental protection and your financials, which you know already, then I think that will be very compelling. Just one last thought about some caution on how you look at your customers, your partners, even academics you might work with. And it's on conflicts of interest. It's a principle that I think about all the time, and who I work with and how you do business. So now everyone's really position is shaped by their inherent conflict of interest. So what I've seen in most policy circles, and you'd be quite surprised that a lot of what we've been talking here, a lot of the opportunities, even a lot of the academic papers that we work on, don't make it into policy circles. The European Commission took only, I think, a few calls, for example, with startups when we were looking at defining some of these green criteria. And the reality is, I hope you get to put your innovations in front of policymakers so they understand that actually the industry can move much, much faster than the incumbents suggest. Because there's a big part of the incumbents that keep whispering into policy circles that the transition has to be slow. And I know you're focused on product, and I know you need to get traction, and probably a lot of you here at seed, pre-seed level, and I get it. You probably won't do that now. But keep it in mind for later, because I'm sure you will scale, and that's when you hit the roadblock. When you actually have to make it meaningfully, you need to be able to address these inherent conflicts of interest in the market. So if I can leave you with 3 takeaways. So follow the money, in particular CapEx from the incumbents, and see how you can pitch this opportunity either to disrupt them or to sell to them. Detect and avoid conflicts of interest. I think it's really the cause of things not taking off and for policy being slow. And don't eat light bulbs, really. Don't do that. So with that thought, I really hope you'll keep in touch with SMU, with the Institute of Innovation and Entrepreneurship, with USI. They're really some of the most incredible and ambitious units of SMU, and I'm grateful they're thinking of me. And I really wish you all the best on the road to Boston. So hope this was somehow meaningful to you. Thank you.
All right, awesome. So the judges are still in their deliberation. Usually they probably take about an hour, so we're expecting like 30 to 45 minutes. The coffee, and I think there's still some snacks that are still available. So as of right now, if everyone can plan to be back here at 3:45, that is the latest. If the judges are finished earlier, we will come and find y'all. So try to stay in this area a little bit. But thank y'all very much. This was awesome.
Hi, everyone. Welcome back. So we've reached the end of the day, and we've heard some really amazing pitches from all of you. And again, we appreciate that many of you have traveled from quite far away to be here with us. So we hope that no matter what, you enjoyed meeting everyone. And we're very excited to announce who will be joining us in Boston. So we have 8 wonderful semifinalists, and 4 of you will be coming with us to join us for our grand final in Boston on April 17th. And we're very excited to announce that Albon, Sidsol, Veriflex, and EarthSprint will be coming to our final. Professor Sunson, if you want to come up for the announcement of. And so now, without further ado, we are very excited to announce that the winner of the Climate and Energy Prize's first ever Asia semifinal is Sidsol. Congratulations. Thank you all so much. And if you all have a minute, if we could actually just have all the startups who presented today come up, and we'll take a kind of cohort photo of all of the Asia semifinalists. Thank you. Everyone come up. We'll be having coffee and tea and whatnot outside until 5, so feel free to mingle and chat with one another. And congratulations, everyone. Well done.